Bismillah, 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 Bismillah. Bismillah, 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 Bismillah. ارفع.
وصلى الله وسلم وبارك على نبينا محمد وعلى آله وصحبه وسلم. حياكم الله جميعا في هذا المؤتمر الدولي 21 الذي يتناول موضوع الذكاء الاصطناعي والاستفادة من هذه الثورة في التسويق الرقمي. نحييكم في جامعة المستقبل، نحييكم في هذا المؤتمر العلمي النوعي الذي حاولت الجامعة أن تقوم بهذا الحدث قريبا من الباحثين في هذه المنطقة. الحمد لله في هذا اليوم أو في هذا المؤتمر سنتناول العديد من الأوراق العلمية، حوالي 46 ورقة علمية منشورة في هذا المؤتمر. لدينا 4 ورش عمل وأيضا نرحب بداية بسعادة نائب رئيس مجلس الأمناء الدكتور هشام مشيقح. نرحب البروفيسور تشاو من منظمة IEEE. نرحب أيضا بالبروفيسور فاروق حسين أيضا من منظمة IEEE، وأيضا المدرب اليوم الأستاذ تشارلز أيضا نحييه هذا اليوم. الحقيقة سنركز في هذا المؤتمر على الجانب العلمي أكثر من أي حاجة أخرى بإذن الله تعالى. نتمنى للجميع الفائدة. حبينا أن تكون اليوم البداية بسيطة إن شاء الله. بكرة إن شاء الله الساعة 9:30 سيكون عندنا حفل الافتتاح بإذن الله تعالى. I am honored to be with us here in Mustaqbal University. I would like to give Prof. Chow to introduce this conference. This is, I think it's
okay, yeah. Okay, right. Thank you very much for your kind introduction. And again, okay, thank you very much for coming to this ICB conference, 21st in series. And my name is Guomin Zhao. I'm a professor in the Roehampton University in the UK. And so it's my honor, it's my pleasure to be here and welcome our Professor Ali, Alisha, yeah. And then our distinguished guests and the speakers here. And so we have a very rich program, and so today it's just a warm-up really. We have a number of tutorials, and give us a chance to know each other, to learn some new technology and a new trend in this area. But tomorrow we'll be doing a formal opening ceremony, and so to organize an international conference like this, it's not it requires non-trivial efforts, and thanks for our organizing committee, especially from the local, local university here host, and then really put a lot of efforts and bring everything together. But thank you very much again, okay, for you. And then again, without our guests, our delegates, to come to contribute, and this conference is not going to be possible. And finally, very welcome again to this 21st years of this IEEE conference on e-business engineering. Thank you.
Assalamu alaikum everyone. My name is Farooq, and as Professor Chow just mentioned, organizing an event like this at such a scale, international conference, is no mean feat. And while everyone in the organizing committee has contributed relentlessly to it, I would like to particularly thank the local organizing committee led by Professor Salim, who is on my extreme right, for all his relentless efforts. Everything that you see here I mean, it's months and months, if not a year of planning. And it's a lot of execution and detail that goes towards it. Apart from him, there are several other people that I would like to thank. And I mean, the conference, as they say, is much more than the sum of the individual parts. Nasser, who is sitting with me, I said this few times, 3 years before, he's the one who initially brought or conceptualized this idea. So of bringing this conference, which is an international conference in the 21st one. So it's not a small or it's not a young conference. It's a well-established conference. 3 years ago, he mentioned this, and as you can imagine, this has been 3 years in the making since then. Apart from Nasser, Professor Salem, I can't see him here, but he has been a key figure behind the scenes in coordinating all the logistics, in making and bringing this to this part of the world. And as I mentioned, we cannot thank enough Professor Salim and his wonderful team in bringing this event together. As you can see, we are very fortunate. We have a very, very rich program over the next 3 days. It's rich in the sense that it's very timely. We will all be talking about artificial intelligence, which I'm sure you're all very keen to learn from our very eminent speakers over today and over the next few weeks, not weeks, days. Having said that, I welcome you all to this event, and I hope you have a very eventful conference over the next 2 days or 3 days, and I hope to be able to meet with you and network with you all soon. Thank you.
Okay, thank Prof. Chow, thank Prof. Farouk. And I would like to thank Prof. Ali Shukr for his accepting our invitation to be one of our keynote speakers during this conference. We are heading to start now. Charles, you can start now your tutorial, please.
No, thank you. Yeah, thanks. Shukran. Okay, so today we are preparing some little gift to understand how the large language model works and how it might work wrongly and how we can correct it. Pretty much like how I learned Arabic. Okay, I have a deeper, better understanding when I learned the language. For machine, they had a different logic, but more computable. So let's see what is going on. Yeah? Is it working? It was working over there. Yes, fine, thank you. So basically for the large language model, we call this a large language model. Yeah, thank you much. And the reason why we call this, it's because it's big, large. Before we start over that, I would like to have some acknowledgement, especially for the people who contribute. We have a lot of people to contribute. Some people I know the name, some people I didn't. One of the things I want to mention is Ms. Barouge, Belafia to Barouge. Yes. He contributed a lot of time with me to combining all the different pieces becomes integration. And also thanks for the professors, all the big bosses here. Thanks for me to give me the chance to show this, the chance to exchange the idea to my understanding of this technology. And we have several outlines. So I'd like to go directly to the core of it. So what is large language model? So large language model, you can think about like a human beings. They're trying to make it more like the human beings, how they process the language. And in the past, it's are more for text-based, but nowadays it becomes more with a better modality. So we're gonna have the detail later soon. Have an example like this one. So you might have some call center experience. In your opinion, if there's a long time, there's nobody pick up the phone, would you like to wait, for example, 10 or even half an hour, or you would like to try chatbot? Yes or no? Would you please try to raise your hand? Who want to wait? Anyone want to wait here? Who want to wait if the call center doesn't work? No? So you would like to try the chatbot? Ah, nice. Yeah, because I have some feedback from other people. They said they would like to wait. And I asked why. They told me that the experience is they don't even want to take the phone call. And that is why the reason we are standing here to bring something better, to make it more humanized, because nobody would like to talk like a machine, talk with a machine. They want to talk with the human beings. It's more interactive. In the past, they have this technology for this chatting, like call center, with script-based technology. And that's why it's not that good, not that human. So they make a lot of effort to create a lot of different script with different trees or different network to guarantee the logic, make the people feel less machine but more human. However, it still had its limitation. After about several hundred sentences, some user recognize this is a machine rather than a human. Okay, and that is actually one of the things why we call it a large language model. Large from script, but of course that is a static one. Now we're trying to build something more dynamic and adaptive. That is how we come from for large language model. So we have the introduction for LLM. Okay, because a lot of people maybe they feel LLM and maybe it's what is it? So in this tutorial, LLM exactly means large language model. And also we're gonna introduce something like a RAG. It's a retrieval augmented generation. Okay, later on we're gonna have a very detailed one. So if you feel it's a lot of not that familiar, don't worry about it. Think about yourself as a large language model now. You're processing my language. And also we have another one. This might a lot of people might be familiar with GPT, but what exactly stand for is generative pre-trained transformers. Anyone knows transformers? Not in Power. Not in cartoon, if you know what transformers is. Okay. Let's take the core technology. Where's the core? So actually, they start from artificial neural network. For artificial neural network, actually start to be the base of the facility of the large language model. Before large language model, there's another one popular term called deep learning. And why it's deep? What is deep? Why it's not a shallow learning? Okay, so deep learning, actually you can see this one. It's somehow represent, you can think it in a simple way. We have an input layer, output layer. You can think about it like the black box. The deep comes from the hidden layers. They have a deeper hidden layers, more the deeper. You can think it in this way, simplified. But later on, they create something, for example, like a convolution layer, very deep convolution layer, dense layer, and a lot of different layers. So that's very beginning of its startup. And now let's jump into transformer. Okay, if you notice transformer, yes, there's a movie there. And for transformer, it starts from the attention is all you need. Actually, the core of transformer is deep learning, but with the attention. That is why how this transformer, now later on we come to the GPT. Basically, we have the training data, training process, and then we have the pre-trained model with the transformer. This is pretty much like how it works. Before the transformer, usually the people use CNN and RNN. But with transformer, why do we need it? One of the reasons we needed transformer is because of training. In the past, in a very long term, for training the deep learning, you need a big amount of the data with labels. Pretty much like a translation, or you need to have one for example, like English, another one is for Arabic for me. So you need to have a label one-to-one. However, it's a very big amount of workload. It's really hard for you to have good labels. Even it's not a good labels. The number of the labels could be tremendous, even unacceptable for the human beings to give a label for each data. So in that case, people think, if we already have data, why don't we use the data itself as a meaningful result? We want to dig them out. So they start to have the one called a deep regression learning. I use the data itself to learn. And how they make the regression. The basic idea is, especially for large language model, let's say language model. When I'm speaking here, for example, Fursa Said. Is it? Okay. Said. Saida. Okay, thank you very much. Fursa Saida. I give the first one. Probably a lot of people might have the prediction of what's going to be the next. Okay. This is the auto-regression for deep learning. Because we already have the data as a context. So if I use some words before as an input, probably I can predict what's going to be the output. And if I have another output again, I make this output, have the check to see if it's correct or not. It's training. And I take this output back again. If I give one word, I predict one. So we have 2 words now. I give 2 words. Can I find the third? If I have the third, give the 3 words. Can I have the 4th one? It becomes sequence. It's auto-regression deep learning. And transformers start from this one. So basically, they need to train the very deep network, use massive and labeled data sets, and it's very expensive, labeling and computational resources, and also time consuming. So this is why they faced before. But after transformer, they're trying to bring the data itself as a learning. So I can use the data itself with the regression. If I give 1, I predict the second. If I have the second, I can predict the third one by one by one. I don't need the human beings to make a very big workload to give me the label for each data. Because data itself can be used as a label or information. So this is how the transformer back the idea. However, for transformer, the core of the transformer, why it works, the core here is attention. And thanks for your attention as well. But what is attention is? Here now, in the computational way, they make it up one attention in this one. Basically, they input a sequence or series of the words or tokens. Each word or each token, you can think about it, each token is one word or phrase or semantic unit. In the past, they even use a letter. If I give you first letter, second letter, or third letter, can you predict the other letters? And later on, they think maybe it's more convenient if they take the token mapped with the word, and then become sentence, and it become paragraphs. This is how they break down into the particle different like element. So if I give the input of the input of the language, so this is X. Let's think about it in computational way. Okay, this is X. I have the query, key, and the value. This is pretty much like a database. Pretty much like a database. Why? Because actually they are thinking, if I give you an input with a query and a key, you should find me what should be the most probable next value. This is somehow they build up this architecture or framework at the very beginning of mindset. So if I give you one word as for example, the first, the second, if I have the key, can you tell me what is the value of this? What is the value of this one? They make it a probability here. So as you can see, we're using softmax to transfer these combinations. You might think it is, wow, what it is. Don't worry about it. We can go detail later. You just need to understand attention is a type of the probability of what's going to be next. And I choose the most probable one to be the next, and next, and next. This is somehow they build up this whole framework. They even to make it within this bracket is the score of the Q, which is query, and K is the key. And they put them together with the position information. They found out what might be the best of the next one. With the softmax to map this into probability. And then they always make this probability matching with the prediction. This is somehow they make this. So if I input 1, it is 1 by 1. But if I input more than 1, think about like, not just a talk like first a Said. If I talk Anna Said, next one, I have 2 input, and I can think about what is going to be next, maybe Bilikoikom. And if I have Anna Said Bilikoikom, what's going to be next? Somehow we have the series of input and we predict the output. This is the basic idea of the transformer, and this is the core. However, sometimes it will make something very, sometimes even ridiculous. A lot of people here might use some GPT like generative AI, and something, the generation result could be unbelievable, not accurate. Even sometimes we call this a hallucination. Hallucination means it will give you something weird. And it's somehow to give you the advantage. For example, when we use the large language model, sometimes we can use it as like agent. It helped me to get a better understanding of the data or text. However, sometimes they had a problem. Why it happens with sometimes we'll give you something weird is sometimes the data, they only know from the data rather than know from the fact. All the work the large language model is doing is not trying to understand your logic. It's trying to find out the most probable result based on what you input. Just like me, I have no grammar background with Arabic, so I listen, I read, and start to predict what's going to be the next. Even yesterday, I know Bilafia sometimes means something different in some other context. I have no idea because I didn't read it before. Bilafia, is that correct? Bilafia. I like the pronunciation. But I have no context and I have no grammatic knowledge. So I only know what I know. Sometimes it might give you some ridiculous pronunciation. Please forgive, excuse, because I'm learning like a large language model now. A walking large language model. So let's see, if we want to solve the problem, what happens? So here we give it one example. What is the capital of the Mars? Do you know what is the capital of the Mars? I don't know, but he knows. He told me the capital of Mars is Elon Yard. I tested in several other models. They give me Elon Village, Elon Town. I don't know why it's all Elon, not Moscow. Okay, so you see, this is one very typical example about the hallucination. The hallucination is that we give you something not exist, just because you read a lot of things. They don't even think about whether this is logical or not. They will give you the answer, whatever the answer, because I give you what you want. You ask me, I give you what you want. But they don't care about whether it's correct or not, because there's no context, no logic. And there might be some other problems as well. First of all, sometimes underfeeding. The training data is not enough. Our training epoch is not enough. We'll have underfeeding. Number two, they don't have the, just like what I mentioned before, they don't have the context understanding. They don't have understanding about logic. And sometimes even the model have its own bias. And if we have time later, we can talk about more about AI fairness. This is another one topic, very hot topic in AI fairness. And exactly it will influence the industry now. And also, sometimes it will cause some wrong decision. Okay, one of the things we meet now today is a lot of people are using, let's say, abuse the deep AI or generative AI in the wrong way because they have no idea about what is correct or not. And they will have the bad customer experience as well. So we here have the several, like summary, we have the efficient, we want to make it the being overcome. We want to put more data in training. We have a better, high quality data for training. And even some data might be outdated. We want to have the latest data. Okay, to my understanding now, a lot of the big large language model, they're using training data until 2023. So if you're trying to use something, to ask them something about 2024, 25, they might give you some unreliable answer. Okay, but they have some fine-tuning team to deal with it. But if you're asking something recently, you need to be aware of it. You need to double check if the answer is correct or not. And sometimes even the model is wrong. But all of this, if we want to solve it, let's say to come for the business. A lot of time now, people are using the agent, use a large language model to solve their business problem. And if sometimes give the weird answer, they will make the customer feel it's not trustworthy. They might turn around and walk away. So a lot of companies now, they start to realize this is a very serious problem, especially when the automation put into use. And it's going to be disaster because sometimes the automation is hard for the human beings to even detect it. It's very subtle. And you don't even have time to capture it. It's gone. To solve it, as we have here, a lot. Some people want to join the team. Yes. Yeah, please feel free to join. If they buy the ticket. So in that case, I listed here a lot of different hallucination. Hallucination here, if you are interested, you can pick each of these in deep, and it could be a very good paper. Okay, but how they solve it? They have two ways to solve it. The first one, they train it. They train the model with a good, high-quality data and with the computational resources, and then put it in to make the model perfect or approach to perfect state. However, it's going to be a long term, and it's going to be very expensive. So people think about, can we have a different way? As what I mentioned, sometimes if I have the context, maybe I don't need to relearn my Arabic again. I just need to check if the context is correct, and then do some little modification, I can start to use it. Maybe it's not a perfect, but at least you understand what I'm saying. And thanks for your generosity and hospitality. You always excuse my little errors. We do the same. We also excuse or forgive some little errors of a large language model. Maybe it's not that human, but it's still somehow applicable. It's fine. So they're applying the similar things, like context-based way, because it's quick. We don't need to change too much about a large language model, and we can put into use. Now let's go back again to check what is the capital of on the mass. Everyone here have, I don't know whether you are not, but everyone should have the experience about it in the test. A lot of tests is closed book. But if I give you open book test, is it easier? Not easy. Yeah, it means I know your experience. It means your teacher give you a very hard experience. Okay? Why? Because hard to find the answer, even open book. They have no idea about where's the answer in the book. So it's not hard for answer. It's hard to index where the answer is. And this comes to RAG. If I give you the open book and I ask you a question, what if you know where the answer is? Would it be easier or not? Won't be easy. Why? So maybe it's, for example, I can't read it, maybe. I can't read it. But let's say, assume, if I can read it and I can find where the answer is, might it be much easier for me to have a closed book test. It's easier for me to approach more accurate answer. This is how RAG did. You can think about it, this is an open book. You can have some underlying note to find out where the answer should be, okay? And then you take it into consideration. You have this note, a tip. So next time, when the people want to ask a question, we talk this as a prompt. Think about like a question prompt. In the past, we put a prompt, large language model, give the answer like a closed book. But now, I set up a database like open book with the index, like the note you take. And I put this as an open book tips into large language model. So large language model have both the question and the most related materials. And then he just need to organize the answer in a human way. That might be much easier than I need to think about it myself. At least according to the materials I have, I could give the best answer according to the context I have. This is RAG how it's doing. So once we have this idea, we can make it becomes easier for us to understand it. We had a documentation, so we have 2 steps before. Because before, we just put it into training and then give the answer. Now, first of all, I have a lot of materials, and I put in the trunk. For each trunk, we have a lot of different trunks, like different underlying sentences or tips. And I put it into the vector database. Vector database, it seems something like a label. Something like a label for you to index where it is for answer positioning. For answer positioning. And I noticed some of you guys take a note. It's a good one, because now you're acting as a RAG. So next time when we want to review today's tutorial, you just need to open your notebook and you'll find out all the things you need. The people who didn't take the note today, they're working as a large language model. They're trying to memorize and training and do some tests. So you see, now you see even in human learning, before machine learning is human learning, you make it a different way. The people take a note is like a RAG. First, take a note. index with labels. When you need to find the answer, you're not trying to find the probability. You're trying to first query, fetch the correct answer, or most probable correct answer, and then put it into prediction for the next words. So the large language model, for this now, they're using their common sense and language capability to organize what you want to query from outside from the database. That becomes much easier to approach the accuracy or the correct answer. So they're gonna make this first query, find the vector where it is, find the closest the trunk, maybe one page, and then put it into the prompt together, combining with the question. All together, put it into large language model. Large language model becomes a writer. He don't need to think. She didn't need to think. Large language model didn't need to think because logic now, it's still very hard for large language model to pick it up. We're working on that one, and we also have some findings. Later on, if we still have time, I'd like to share with you to see what we're approaching. So for this one, they avoid the computation for logical thinking. They just need a context. And if you can guarantee the context is correct, next one is writing. So large language model only working on writing rather than thinking. Even he can think, very little one. We just use its advantage. So as a user, you need two branches. First of all, load the data, which is the probable answer or materials, split it into text chunks, embed in the chunks, which is vector, and then store and embed DB, which is database. And then when you prepare all the things ready, next time when you want to ask a question, they're going to retrieve the chunks you prepared, and then put it together with your question and the chunks or your context together to give the answer. We just need to have one more branch, and we overcome the weird answer problem. So let's see the benefits. First of all, it's more reliable. It still have the chance to give the wrong answer or weird answer, but it's acceptable. If sometimes give you the answer, if you think it is not reliable, with the same context to do something twice, 3 times, even several times later, more, you will find the correct answer. So it's reliable, easy to use, at least for this short term. For long term, we have another one approach, another one branch to do it. And we make it simple, quick. We don't need to change too much about a large language model because it's very expensive. We already have something. We don't need to destroy and build a new one. Save our time and the money. So if we want to make them all together, how we can make it autonomous together, rather than we just need to do as a human beings do once and then do another one. This is the one we are now trying to build up, which is agentic context large language model, or agentic RAG. And RAG is one of the agentic context. It's not one of them. It's subset. So basically, the client will firstly give the question, and we set up one agentic context, or say RAG agent. It will process the question and use the question as one clue to index what might be the most probable data or answer, and find them out, put them together, pack it up together, and regenerate a new prompt rather than the old one. Use this new prompt, correlated both the probable answer and a question together, and then put it into a large language model. And then a large language model just need to organize the answer and put it back to the agent. Agent will pass back the response to the client. This is a very simple, straightforward one. Today, they're trying to improve it, even enhance more. Agentic context agent can somehow even judge whether this is reliable or not. So which means you have another agent. I have 2 agents here. Yeah. You have another agent help you to check whether the answer is reliable. So always you can guarantee you, no matter how they talking, how the agent talk with large language model, when you get the answer, you talk with the agent is always most reliable one. That's why we need agent. Mashallah. So let's see what we need to do. User give the query. RAG system, RAG itself, will have the retrieval, knowledge source, generator, back to resource. As you can see, you're not talking to the large language model directly. You're talking to the agent system. An agent system talk with all of this, even without you, even without your input. Agent system can always talk with large language model agent. They can talk with each other. Hey, you didn't do a good job. Oh, what's going on? Oh, you did this, and it doesn't work. Okay, I double check. So even without a user, it's still a closed loop system. It can make it its autonomous evolution, self-learning. It could make it self-learning. So before you use it, they might already learn 1,000 times. So next time when you come to learn, when you come to have the query, they'll give you a better, reliable one. And here now, we would like to give it a case study. So our case study is really, this is one of the real one. This is a real project. This project is led by Professor Farouk. We're working on carbon credit one. And in the past, it was an idea, but now it becomes more and more real. And there's one question. What type of tea is hard for you to swallow? What type of tea is hard for you to swallow? Which tea? You can swallow whatever tea, isn't it? The harder one. You can still swallow it. I told you, it's reality. Why? People, it's easier to get the point of virtual, but hard to get in the real. Carbon credits somehow both for virtual and real. And they need to have one thing to make them together, bridge the gap from the virtual to reality, make it easy for us to accept, or let's say, easy for us to swallow it. So that's why we need a large language model and AI. Large language model is one of this. It's more for human beings. But behind large language model is computing. A lot of people think it is not reliable because this is virtual. But if we can build one-on-one data mapping, it becomes more reliable. And this is how we do it. This blah, blah, blah about like carbon credit. Next tutorial, we're gonna have Asma. They're gonna have a better, easier, more explanation. She has a better context than mine, especially in Arabic language and a culture as well. So basic idea is we're trying to reduce the emission of carbon dioxide emission to cut down the greenhouse gas emission. And this can somehow, as a reward for the sustainable development. But in the past, the people don't pay for it, so there's no bridge to bridge the gap. But now there's several financial institutes to build up the new rules to force the people to know you can't develop something harmful for your next generation. And this is a type of tool. So with the carbon credits, they can have an incentive, the different companies, to invest in sustainable practices to make it more environment friendly. And I think this is one of the things we can talk later, because I noticed Saudi Arabia have a big chance to be a seed player of this new emerging technology. So we want to have the role to change the migration of the carbon credit. And the carbon credit, if you save it, now it becomes a set. If you have an idea about a real world asset, if you did, you might know what I'm talking. and it's a new e-commerce or business concept. And it's for sustainable development. Think about it like energy. All the energy is set as a real one, as what I mentioned. How you can bring this becomes a reality. If I can prove, if I give you the information exactly one-on-one, the real world, the data becomes real, tangible. So let's see. In 2022, we had 1.5 billion carbon credit traded. Okay, and we have averagely the price is about $45. You see, people buy it. People buy it. Reduction, 20%. And also, estimated economic impact will be $1.2 trillion. And now, 50%, the proportion of the company, they're integrating their carbon credit into their sustainable system. And I'm very lucky. I have some experience in some very big giant. Later on, we can share. They are embedding their carbon credit system, become a part of their compliance. As you can see now, we have these figures. You feel it's real more, rather than just like, oh, it's just something you made. But if I take this bridge, the gap between the virtual and the real, you think it is more like a set. So you see, query. Anytime when you buy something, and you always keep an eye on it, you can control, you can estimate, you can calculate, it's more real and meaningful. This is how the new generation of the e-business is coming. AI and the data. This is a very great chance. Not many people understand it. That's why it's our chance. And so you need us. Why? Because we need the data and AI. So think about it. This is one of the systems we designed. Another one, very left-hand side is actuators, like drums, like greenhouse, even tractors. And for this part, operations, trading, policy, even compliance, they're all real. They're all real. But in the several years before, they don't have the gap. Now we have the gap to bridge what exactly happened and what will happen in the market. I bring these two together, and it becomes more tangible. And that's why we need to have a lot of the components. However, it's very complicated. It's nearly impossible for a small company to afford this big system. So we want to make it automation. And a lot of the time, they need a very big data. You need to have the very quick index of what the factor you want. We build this up. And one of the things you might need is RAG and large language model, because they have so many different projects. As an investor, if I put $1 million in one project, I want to know how much is it for value. How much, if I want to transfer into the market, how much money I can make as a businessman. So in the past, you might go to ask some consultancy for a consultancy. However, for now, you just needed this. If our RAG can find you the right answer and give you the large language model to organize as like a real report, your submission could be very quick. You don't need to have reorganize all the data, have several weeks to organize a report from EY, KPMG. You just need us. And then auditor, accountant just need to have a review and have a signature on it. So we're not trying to replace them. We're trying to help them to upscaling their business. Okay? So basic idea is we have the interactions. User will have the loaded data, return the documents. Before that, all of this done before is by human beings. Now we make it as all autonomous, automated. So this becomes more acceptable now. You don't need to set up a 30 people or 30 staffs company. You just need to use 1 or 2 of our tools, and then you can organize your own business. And in the next part, we're going to have a tutorial. We're going to show you an example about how to set up the large language model for our carbon credit system. As an investor, okay, you invest. You want to know, you put $1 million in different projects. Are they growing well? Do you want to take money out, or you want to put more money in? Decision making. But in the past, it's very hard. We're now trying to use our system to make it easier. And we're going to discuss several. For example, the question, we try to have one of the questions, typical one. If we ask a question before 2023 and after 2023, you will see the differences, and then we can discuss it. And this is the case study practice. We have the sharing on the collab. So next one, we're gonna have practice, and maybe you can also try to see if you can link in on it. And thank you very much. Thanks for your time. Any question? Shukran. Any question? Yes, please.
Thank you very much for your presentation.
Thank you.
Okay, it's very comprehensive, very interesting. Just one quick question about, you talk about split data documents.
Yeah.
What does that mean?
Split data document. Okay. In the past, we trying to organize the knowledge, let's say, the knowledge. We have a different way. The very easy way, because we're lazy, we don't want to have our mind to work it out on the score. So what do? We directly put the book in. However, in that case, when you have the book in, some people just give me the book. However, they can't digest this long context. So we need to split it into several pieces, maybe one sentence or maybe one paragraph, exactly matching with the answer. So we set up a different thing. First of all, we make this embedding as a vector. And then the question as a language text can be a vector as well. So when we have mapped those two texts into a vector space, we can use some tools, for example, cosine similarity. To use the similarity to help us to find the top 100 different pieces of the index. And then once we have the index, we use the index, we find the corresponding paragraph, and then put them together as a bulk. This is how we split it. Yeah, thank you very much. Is it somehow answer the question? Yes. Thank you. Actually, I try to hear, I can't hear very clear. I thought you said you're very handsome. I'm very happy that moment. Yeah, but you have good taste. Yeah, any other question? Yes, please. With the technology? No, for hallucination?
I will ask the question second time. What are techniques that we use to reduce hallucination when the output is very critical, like source code or formal models?
Oh, okay. Well, very good answer. Very good question. For me, is basically they're gonna have different way. In the past, they put whatever the things into large language model. However, nowadays they're using one technology called MOE, which is to have a different expert. Some expert only focusing on program, some only focus on mathematics, some focusing on maybe literature. So they will find, this is very advanced because we didn't include this one in our tutorial, but I would like to share. Basically, the idea is the similar. RAG is for document. MOE is for model. So when you give me one question, I use this question to, for example, put it into the vector mapping, and I use this vector index both document as a context, also the model, to see which one have the good expertise. And then merge the good context and a good model together to give you the more reliable answer. This is one of the technology they're using now today. Does it make sense? MOE. Yeah. Yes, yeah, I noticed that. Yes, please.
Thank you for the presentation.
Thank you.
That's very interesting. So my question is that you have an agent on top of built on based on an LLM model. So how dependent it is, the accuracy dependent on the LLM model, the underneath model?
Yeah. Let's see. One is you can think about like it's more like you want to improve the student or you want to improve the answer. If you want to improve the student, LLM training, definitely. If you don't know the answer, go back, practice, learning, do some mistakes, I correct it. But if you want to train as a good answer, even I do not have any idea about Arabic, but if you give me enough context, I might can somehow find it, how to write it. So it's one thing about, are you focusing on answer or you're focusing on model? For the equivalence, it depends on your need. If it is very, just like indexing, document is enough. But if you want to have a deep think, you have to go back to have a lot of training for model. Yeah, this is to my understanding. Does it make sense? Thank you. You're very polite. Yes. Yeah, it's fine, yeah. Thank you.
And do you consider the feedback and a mechanism for continuing improvement? Like usually for system, it should be closed loop and continue to be improved. Like you got feedback and improve the right, improve like adjustment mechanism and make a closed loop.
Well, it's actually a very interesting question. First of all, a simple one, yes. But for long term, it is yes. But for short term, maybe yes and no. There's two things. First of all is we are standing in the age of explosion of information, data. So you might can have fine tuning. However, sometimes maybe today you're fine tuning. After several, like a period, the knowledge is being updated. How you can catch up the speed of the update of the knowledge? If you can, yes, approaching. But if you can't, which means you're approaching, but it's out of date. So it depends on long term or short term. Theoretically, in long term, we can approach the best answer. But what's the best? Because all the things is changing and quicker, faster now today. For a technical side, we have several ways to do it for model, let's say. For example, now, you know, LoRa, the model LoRa. Actually, it's a fine-tuning technology. Now today, people use it as a model, but actually it's a low-rank R for metrics, to my understanding, or low rank of metrics. The best idea is, if I have a big model now, I don't need to retrain the model. I will keep the biggest part of the model frozen. And I just add one layer. And I just fine-tuning that layer, which means I don't need to spend too much money and time on fine-tuning whole model, but I just need to have the output. It's similar to what we talk, focusing on answer rather than focusing on the thinking. But there's another one. They called reinforcement learning, if you heard it. That is focusing more on thinking or model itself. But it's still very hard. What they do, they're using reinforcement learning with human feedback. It's RLHF. So with that one, which is actually ChatGPT 5, 3, start from 3, they're using this technology, make it very impressive update. So at that moment, we think, wow, we're approaching the right answer, until they give the weird answer. So when you say approaching, it depends on short term or long term. If it is on a specific time period, yes. But for long term, we need to have a better, how to say, more struggling on computational resources, time, data, a lot of things. So even today, I believe a lot of people think it's very powerful enough. It still have a lot of work to do. So if you're interested in, it means we can work together. And if we work together, we won't be replaced. We won't be replaced by it, at least for now. Okay. So if we want to have more time, we can talk in deeper about it.
Yes, actually there is a hot area, and many like companies and many technology, they are developing some mechanism and models. Okay.
Yes.
Thank you. Thank
We
you.
are open to whatever the opportunity for industry, for academic, or even for interest. So it doesn't matter where you are. I believe everyone had a good idea. I'm standing here just because I have the chance. But if you have an idea, a lot of people keep silent. Just not because they don't have the idea, just because they want to play a low profile. You're very humble, I know. But I want to dig you out. Okay.
Okay, good.
Yeah,
Very
thank you
good.
very much.
Thank you.
Any other question? Yes, please. Oh. Lady first, and then we'll come back. Yes, please.
Hello. Hello, do
Yes.
you hear me? Thank you for your presentation today.
Thank
It
you.
was amazing. I have this question about the transformers. In your opinion, do you think it's a shift in the deep learning, like regarding the CNN? You mentioned that it's better than the CNN. So I'm asking, is it a shift in the field, or is it just like an adding architecture for it?
Okay, thank you. Actually, a lot of people discuss this as well. To my understanding, each framework has its own advantages, according to my experience. For example, I have a very practical project. We use deep learning. However, the result, you can't believe it. Believe it or not, logistic regression have the best performance. It doesn't matter, actually. So this one is the same for transformers. Even transformer in a lot of different tasks, they have a good performance. However, it's still case to case. It's not an almighty model, but sometimes it has its advantage, especially for context. If you want to know the sequence for different elements, the relationship between different elements, transformer sometimes will give you more attention or different explanation. But for some time series, if it is very simple or not that hard, maybe you can try some other model as well. So in that case, you need to balance between not only just performance or expectation, but also how much the computer resources do you have? How big the model, how long time, and how much is your budget? And what's the data? To my experience, if you have a very big data set, maybe you can try some big model, for example, like transformers. But if the data set could be not that, not that tremendous, you can start from the small scale. One of this one is called a PINN. It's only specifically for scientific computing purpose, which is a physical informed neural network. That one also good as well. It doesn't have to be a very big one, but of course, sometimes you need to know why you use this model and what's it for. For that one, it's a long story, but we can talk after this one. I noticed some people, they might have waiting for the team break. Yes. Does it make sense? Yes. Thank you very much. And Professor, thanks for your patience.
No problem. I just had a question in relation to, in the last few years, especially last 2 to 3 years, we have seen a dramatic explosion in the number of large language models.
Yes.
In the last few years, we have seen a steep increase in the number of large language models. We initially had the likes of ChatGPT and Gemini, but there has been a lot of increase. It's fair to say that these large language models, they have become a utility these days. Everyone is using that utility. And that leads into the concept of having sovereign capability in large language models,
Yes.
especially from a security and from a privacy viewpoint.
Yes.
If you can just elaborate a little bit on that. I know that's very far away from your tutorial,
Yeah.
but there are huge data governance, data security, privacy issues why many countries are moving to develop sovereign capability in these models. If you can cover that, that will give everyone a great idea.
Yes. Actually, this is a very important point. So basically now, it's a very big ecosystem. No matter you're working on algorithm, model, data, you always can find your position. That's why I said it's a very big chance. For example, in Silicon Valley, they have several companies only focus on data. They guarantee the data they're providing with a reliable quality, high, trustworthy, reliable. And with this data, the large model doesn't have to cost $1 million to run on the useless training. They only focus on the training resources for the use for quality data with the better answer. And they save it. How much did they pay? They said they paid about, every year, they pay about 1 million. But their efficiency is more than 1 million. So it means if you pay 1 million in for computing, you should pay this 1 million to the data before you pay for the computing. You need a guarantee it's not a rubbish in and rubbish out. So, and the sovereignty as well. For example, in Saudi Arabia, they have a very specific data. For Australia, they have a specific data as well. However, sometimes they are not compatible because not everything is common sense. Especially you're working on something very deep, very professional. You should not use your common sense. You should use something reliable with knowledge and logic. So this is sovereignty. So in that case, data and also model and knowledge information become a set. So today we get the one called as carbon credit. In the future, we might have another different credit. Gonna open a new world to us. And thank you very much for professors. You just remind me we should mention something very important, and we're open to the collaboration. Oh yes, please.
Thank you very much. Nice presentation. Just a question on the aspect of environmental impact of that computation, and because it's increasing, the computation is increasing. So in terms of sustainability, I don't know, I know that this is not the related topic, but
it's fine, it's
like, so it will have huge impact, I guess, what you are proposing, right? So, or advanced, as we have advanced models, it will have huge impact on the environment as well. Is that right? So,
You mean for the quality of the model?
for sustainability, so basically the sustainability aspect of the computation of AI models, yes.
You know, it's very interesting. Even large language model now, it's not as sustainable. You know, a lot of the giants, they're trying to build up a nuclear power plant to support their computing. They said even as one, like a deep learning center, they need to consume the power equals to one city or several cities. So it's, in the long term, it is not sustainable. So for sustainability, we need to think about it both for human beings and our development, and also for model. Because this, it's a technology, we should put it into the right use, rather than we do whatever we can at any cost. It is not reasonable. But however, for different country and different area, they have the different resources ecosystem. They have the different economics, scales, size, are quite different. To my understanding is, first of all, the carbon credit could be serving as a good example. If you can somehow combine what you put to make it as a set, the people have the understanding about the value, and then they would understand what they should do in the long term. And there's one called a real world asset. This is one of the things raising. It could be one of the channel we can step into. And it will have some other technology as well, like blockchain, cryptocurrency. It's more like a finance part, but for our side, it's immutable, reliable, transparency, traceability, and also trustworthy. So if we can build up, again, virtual and real, if we can bridge the gap, I think we can make it a better, efficient sustainability in terms of the Let's go to team break together. Thank you very much again. Thank you. Thank you.
بسم الله. بسم الله. بسم الله. بسم الله.
Now we will start the next tutorial with Dr. Asma. You can start. Thank you.
Assalamu alaikum. Okay, let's just wait for the slides. Yeah. Today, inshallah, we'll talk about the carbon credits. Charles has already introduced some concepts about it, but we'll talk in details about the carbon credits, the concepts, the net zero, and the reduction of emissions. That's like the subject that everyone is talking about now. It's the climate change and all the weather, the changing in the weather that we have seen and how to tackle all of that. So we'll be talking about it from the technology direction point of view. We'll talk about how autonomous agents, smart contracts, distributed ledger, and blockchain will help into achieving the net zero emissions for real. So we'll talk about some of the challenges, and then we'll introduce the technology and how that technology will solve the problems. My colleague, Asma Mistadi, Dr. Asma Mistadi, is joining us online. She couldn't be here today, but she says hi to everyone. So we'll start with a background about what carbon credit is, how it's created, what's the role of carbon credit for now, and then we'll talk about some of the current challenges in terms of integrity of the carbon credits, and then we'll talk about the technology solutions, the applications, and finally we'll talk about the future direction for research. Let's see. Asma, you are with us? Is team connected or?
Hello?
Hello, Asma, hi. We hear you.
Yeah. Okay. In this slide, I'll present what is a carbon credit. We'll start with that. A carbon credit represents 1 metric ton of CO2 emissions. You could be wondering, what does that look like? You can see in the picture on the right, the size of 1 ton of CO2 emissions. They were primarily devised by the Kyoto Protocol under the cap and trade as a market-based mechanism to reduce greenhouse gas emissions and to eventually mitigate the effects of global warming. Carbon credit create monetary incentives for companies to reduce their carbon emissions. As a result of this mechanism, carbon markets were established to trade carbon emissions. Next slide. Okay. There are mainly 2 types of carbon markets, the mandatory markets and the voluntary market. The mandatory markets are regulated by governments and authorities and are high, while the voluntary markets are highly unregulated. Participation is mandatory in the mandatory market, while it's non-mandatory in the voluntary market. In the mandatory market, each carbon credit represents a permit for emitting 1 metric ton of CO2 emission, while in the voluntary market, each carbon credit represents a reduction or removal of 1 ton of CO2 or equivalent greenhouse gas achieved by a carbon project. The voluntary market is a non-compulsory market where public organizations and even individuals can gain carbon credits and trade them or buy them to offset their carbon footprint.
Okay, so to complete the picture about carbon credits and what they are, we have to start with the life cycle of a carbon credit project. So carbon credits, as Asma stated, they are serving towards net zero, so they are serving towards reducing the emissions, reducing carbon. There are two ways for that. One, which is the popular one, to reduce the emissions from any company that they are emitting so many CO2 into the atmosphere. So their goal is, okay, let's reduce the CO2 to the minimum level possible. The other one is actually to absorb the CO2 that's in the atmosphere already. So we want that to be gone as fast as possible. These projects usually more into the agriculture and more into the reforestation, which is rehabilitation of so many forests that they were gone, and then try just to replant them again. So for any project in the carbon credit, they start with establishing the baseline data. The baseline data are the giant here, where we are actually claiming what's going on, that, okay, there is actually a consumption of carbon, or there is a consumption of materials that emitting so much carbon, or there is a carbon already there, and we're trying to reduce it. So that's the baseline data. That's where we are claiming the current situation is, and where so many of the problems will come later on related to the claiming of the baseline data. So what happens here, okay, this is what we have. This is the current situation. This is how much we are emitting, and this is the what we are trying to achieve. So they go from there to activity execution, which is their activity to reduce or absorb the carbon existing. And there are so many registries out there who will check and verify their methods and approve it. Most of this work is related to more into the environmental engineering side, but we're trying to help them into fixing all the issues that they will be facing, or they're facing actually right now. So then from the activity execution, they will move to the third phase, which is reporting and verification. At this stage, they will verify their execution of their activities and how their results differ from the baseline results they were claiming. And in this case, step also, we are facing so many integrity issues, so many unverified claims. The verification and reporting, the reporting first done by the company themselves or the organization who are implementing the project, and then the verification is done by a third party. Both are human, so prone to errors and missing so many important data, also prone to making intentional mistakes, which will result into false carbon credits or false reduction of emissions. From there, they will get their credits issued by the registry, whatever registry they're using. I'm not sure if you have heard of any registry already, but have you heard of Vera? No. So Vera is the giant registry, #1. So think Google for like computer science or IT. Vera is #1 for carbon credits. There are many others, but Vera is the well-established, they should say, and we'll see how many mistakes they have made already and how we're trying to help or mitigate these problems. So from the credit being issued, they will sell them. That's the point of making actually credit. Most of the companies, they trade credits as more of a financial instrument rather than helping the climate. So they actually implement these projects from establishing the baseline to activity execution, which costs a lot of money, to reach to this point where they actually trying to sell and commercialize their product. So it's more of a exchange of money for product, which is, in this case, is carbon credits. The price for carbon credits range between few cents of dollars to say, even we heard $120 US for per credit. Some of the projects, they were claiming even $150. So this is how much they will benefit. And for each project, they will at least produce 2,000 credits to be financially benefit them. So you see like 2,000 credits by $150. That's a lot of money to just think about. After that, the purchasing company, what they will do with the credits, actually, they will retire them, what we mean by retire them is offsetting their emissions. So you see like so many companies that would say, we have reduced our emissions, we have contributed to sustainability practices, we have done our part. That's what they mean. They actually purchase credits from someone else who had already reduced their emissions, and then they retire it to claim the reduction of their emissions. So this is the life cycle of a project, and there you can see so many points where any person can make claims. Finally, the retirement is an issue again because they can sell their credits to so many partners. And as a result, so many people will be retiring the same credit using them to offset their emissions. And that's a big issue if you're using, it's like more of false money. You cannot purchase anything if you lose integrity of the money you have. So these are the main challenges. Based on what we have discussed so far, we limit the challenges into 4. That's the ones we can actually solve with technology. There are others where you have to solve with science and environmental engineering. So the first one is what we talked about last now about retirement is double counting. What they do is actually generate more than one credit from the same activity. So it's like you just copy your work and make multiple copies and start selling them. And that's an issue if you cannot verify the original source of that. So we are not achieving any offsetting of the emissions if we're doing double counting in that case. The other one is greenwashing, which is also equivalently dangerous. In this one, what they will do actually is, what I mean by what they'll do is the project proponents who are initiating the project, what they will do in this case, they will claim some actions that reduce the emissions, which is false actions. They haven't done anything. They were, some of the projects, they were planting trees and getting the emissions and then cutting the trees, which contradict the point of actually planting the forest again. The third one is lack of transparency. For these projects, usually they have their baseline data semi-published, so it's not published to everyone, it's not made public, so not everyone can actually verify their claims, the base claims, which make an issue later on once they announce their results and of their actions or whatever methods they have implemented to reduce the emissions. You cannot verify that it matches the baseline data. The only organizations that verify are the registries and a third-party verifier, which is mostly an auditing. It's similar to accounting and auditing. This one is more for carbon credit. So this is lack of transparency. If the verifier have low integrity, that's an issue because they actually exist. They will result in false claims, and finally, they will result in false carbon credits. Finally, it's a time-consuming process. We have worked in a few projects, and it took us a few months, up to a year, to just establish the process and think about what data we should be collecting from the beginning, how to reduce the emissions, think about all the technology available. What I mean by technology is sustainability technology in terms of like new batteries, new practices for agriculture, and all of these. So to think about all of the methods they have to follow, and then implement the actions, submit to registries, and then implement the actions. All of this is time-consuming and financially hard for most of the companies. So that's why they might rely into like lack of transparency to cover some of their bases if they are trying to cut short and claim some of the false credits. So from there, now we have all the issues like listed hopefully clearly. One of the examples that we have, because of all of the double counting and greenwashing, the carbon credits integrity has dropped from this year. From 2021, we had 2.1 billion in sales or for voluntary credits, and dropped in 2022 to 1.9 billion. And later on, 2023, it dropped to 723 million. So we went from almost 2 billion to 723, and then again it dropped. All of that because of the lack of integrity. So buyers actually moved away from buying these credits, buyers who were claiming that they want actually to offset their emissions, they want to make their practices more sustainable, they want to do good for climate change. So as a result, they actually moved away, and also because of all the issues with the other projects, other proponents who were starting their projects, they moved out. This was a big market. The estimation was to reach 10 billion by 2023. Unfortunately, it has dropped to 723. The reason why the drop happened here, because so many of the projects or so many investigators, independent investigators, found so many projects that were false claiming their credits. One of them was in California, where they were actually, their baseline was not actual. What they did was, okay, let's take the average of all the available projects and claim we are similar to them. So that was not actual baseline. They were actually just getting the average of whatever practices currently. They did not take into advantage any of the current environmental changes. They did not take into advantage any of the regulations. So that was one of the projects. The other one was a project where actually the proponents made false claims and ended up with what we call junk credits, because the credits, once the verifiers went back to check them, there was no claim, no real actions. As I said, one of the projects, what they did was they claimed they were reforesting some parts in south. It's near the islands, near Rigi. What they did actually, after 2 years, they were logging. They were cutting the trees down, and it ended up with like as if nothing has happened. We don't have the trees that's supposed to be absorbing the credits. One of the main things about carbon credit projects is they actually live for at least 7 years for small projects, and then once we start with the bigger ones, we live up to 30 years, and for some special types of the projects, they live actually to 100 years. During that, they will live their life cycle of monitoring and claiming credits every couple of years almost. So this is one of the reasons why the drop happened, because they found the claims were false and nothing was actually happening with the credits. All of the buying was false. One of the other problems is actually we have some companies started like coming out where they work as verifiers to verify all of the actions of the companies claiming actions to reduce carbon credits. But these companies started from $1 million per project, just to verify that this project is actually claiming the right carbon credits, and they are actually implementing their offset. So you see how much money is being wasted, I should say, in like just confirming the credits need to be real. One of the studies found 1 out of 26 of each 26 projects to be real. So the rest, the 25 projects were just false claiming. So this is one of the other issues we are facing. Mostly it's garbage or junk credits. So we'll try to address all of these issues using technology. Sorry if the introduction was long, but it was necessary because most of the communities do not actually use carbon credits, so it's not something everyone knows. It's recent innovation, a recent way to reduce emissions. That's why we're trying just to help with technology to integrate it. So we'll try to do first, double counting. Double counting is just, we try to make the credits unique so they cannot resell them. The first one is we'll be using the digital identities. We'll use tokens to just reduce the probabilities of the credit being copied. With the token, we'll be having all of the metadata of the project, including the project proponents, the location, the baseline, some of the baseline data included, and the method they will be using to reduce the emissions. The other one will be using these real-time transactions. These real-time transactions will follow the path that the actions take from like using sensors in the ground up to issuing the credits. The reason why this is necessary to eliminate double counting, so they cannot use the data they have later on to issue another credit. They might use the credit themselves, resell them, or they may actually use the data to generate another fake project and then claim carbon credits from this one. So this is for double counting. For the other issue with verification and transparency, which is, I should say, more advanced and much harder to solve than the other double counting, we're looking into the multi-source data validation. So we have the data coming from different sources, especially sensors in the ground. We have some projects using satellite imagery. We have some of the projects are actually using manual reporting, which is hard to verify, but we'll cross all of these data coming out, and then based on that, we'll try to verify the results that they are not claiming. Sensors should not claim if they set up in the right way, so we'll end up with the right data. The other one is automating the monitoring, reporting, and verification systems using AI, just to check if there are any anomalies in the reporting, if there are any false reporting, or if there is any divergent from the baseline that cannot be approved, cannot be real for given the current situation. Finally, we'll be using the blockchain audit trails to store the main data and then prevent them from being mutated or being manipulated. Asma? Okay. Asma? Asma, you are with us? Okay, I'll continue until she joins. So the solutions we are suggesting is to use three popular components: blockchain, AI, and IoT, and try to integrate all of them to reach to the result that we want, which is eliminate double counting and improving the process of verification and validation. So the blockchain will be used, as we said, for transparency and for provenance management.
So blockchain, AI, and IoT can be utilized in this area. Blockchain can provide the transparent and mutable records of carbon data, and enhances their provenance. Also, AI can be utilized in carbon data and carbon credit monitoring, the detection of abnormalities, and prediction of carbon emission data. IoT also can provide real-time records of carbon data, which could improve the trust in such markets. Next slide. And management from blockchain, AI, and IoT can be utilized in this area. Yeah. In this slide, we'll get to know some of the basics of blockchain foundations utilized in carbon credits. NFTs are non-fungible tokens, which are unique certificates stored on a block and serves as means for representing ownership of unique items. So we can utilize this by representing a carbon credit as NFTs, which will then we will have a clear record of their ownership history and their trading history as well. Blockchain technology is a distributed decentralized digital ledger that is used to store data in a reliable manner. Smart contracts are programs that run on top of the blockchain when certain conditions are met. They are the building blocks of decentralized applications. The rules for minting, exchanging the NFTs live on smart contracts. Tokenization is the process of representing assets as digital tokens that live on chain. Decentralization in blockchain refers to the transfer of authority and control from a single central entity, like a bank or a government, to a distributed network of participants. Moving to the next slide, please. We have developed a prototype to demonstrate the use of NFT in this area. It is a decentralized application that is used to mint carbon credit as NFTs. It has several services, mainly a minting service and a trading service. The user can fill the form manually or upload a representative image. And they can simply provide a link of the carbon credit metadata and then provide the price and the mint their carbon credit as NFTs. As you can see here in the profile page, the carbon credit is minted as an NFT. And they can also be seen in the dashboard here with all their data, like who's owns the carbon credit, what is the ID, so full transparency. The owner can also list their minted carbon credit NFTs to the marketplace, where they can be traded for financial gain, as you can see here in the demonstration video. Where they list the NFT, and you can see it next in the marketplace. So moving on to using AI technologies for carbon monitoring. When we represent this carbon credit as an NFT, it's easy to monitor. Using Gen AI we can utilize Gen AI during the tokenization process, during the minting process. Once the carbon credit is represented as an NFT, it will be easily monitored and tracked. The minting process is mainly 3 phases. Image upload, this includes selecting a representative image of the NFT. The second phase is metadata generation and upload. The third phase is the actual minting of the NFT. Gen AI can be integrated into the first 2 phases. It's just an example of what can Gen AI do in our prototype. So we can generate both the image and the metadata, which was actually implemented in the prototype.
Okay, so besides what Asma has mentioned about using AI technologies for confirming the NFTs, we'll be using technologies also for the confirmation of the computer vision and all of the satellite imagery we have received, especially in the baseline data. Also, we'll be using them for contribution into the project themselves and the project activities themselves, and then how we can improve that side and how we can reduce the emissions even further. Finally, we'll be using them for real-time processing during the verification stage. During the verification stage, what we face actually is we have the data coming from different sources. We have data coming from manual entry data. We have data coming from sensors, ground sensors. We have data coming from satellite imagery. We have data actually coming from other reports. So what we want to do is use AI to process all of this data and detect all of the anomalies there. what we face, what we have seen actually with the data coming, first, the sensors were, sometimes they were manipulated into claiming more reduction or more sensing of reduction in the carbon credits. Also, the manual entry was not accurate. Sometimes it's intentional, yes, but some other times or many times it's unintentional where they actually entering data by mistake. Just it's easy to miss a number or enter another zero to just claim the credits were greater than the actual number. Finally, which is holding all of them together, is the IoT integration. IoT integration is very important here to try to eliminate all of the manual entry of the data. What we'll do with the IoT integration is to plant sensor, ground sensors all over the project, or if we're using, like if it's moving trucks, then we're planting the sensors on the trucks themselves. We'll try to streamline all of this, which is not an easy process. The problem with streamlining the process from the IoT sensors is first, you have the sensors placed in remote areas sometimes, so you don't have any network connection. And you want this data to come as a stream and to be on time and sometimes in real time data to just verify and confirm. So if we cannot actually stream them directly to the main server, we have to back them up at some safe place and then to be ready for the verification process. The other issue is the streamline of data is actually generating huge size. So what we want is how can we streamline all of the important data and then end up with enough data to verify our project. Finally, what we want to achieve is a data-driven approach where we are actually using our sensor data fit into the AI engine and the blockchain to create the immutable credits. So we have two examples here. The first one is the agriculture, in the agriculture sector, where we were implementing a soil sequestration project. In this one, it's one of the types, as I said, one for sequestration, the other one is for offsetting. So for sequestration, what we are trying to do is remove the carbon from the atmosphere. In this one, they were planting trees to absorb all of the carbon in that area using the ground method, which is using the soil to sequester the carbon by their roots. The other one was the tree itself. It will sequester the carbons through their leaves. So that's the project. We implemented some verification analytics and immutable record. And here is the flow chart for the project. First, we have different devices collecting the data. What we faced with the devices was first, integrity of the devices because they were in remote areas. Agriculture areas are remote usually. So we wanted to verify the data are coming from the right place, also from the right location. It's not only the general area, but it has to be placed according to the methodology in different and specific locations depending on the GPS or latitude and longitude location. Then all of this will be pushed into the buffer using a stream of data. And the main step here was the quality assurance of the data that's coming from the sensors. The issue with that one, first is sometimes we have interruption in the communication, so we are not getting all of the data we want, so we have to replace them with manual entry. We have the backup there. So just to collect all of that, we had to do some quality assurance and geotag all of the data to prevent any double counting later on. So what we did was with the quality assurance, we have the geotagging and we have the other thing, which is the anomaly check. The anomaly check was done in collaboration with some environmental engineers where they actually established all of the necessary functions. And we fit that into a smart system where they were checking if there is any divergence from the real data that's expected in that case. If there are any anomalies, they needed to be reported, and then they needed to be confirmed in the ground and on the site. All of this was stored in the blockchain to create immutable registry of the data we have. But the issue, again, it's a big data, so we cannot store everything in the blockchain, and it's meaningless to store it in the blockchain. So we hashed the stream of the data. We received the data almost every day as a streamline. But for the hashing, we decided, okay, it's done for every week for this project because the sensitivity was not high. And just to give you some information about the verification process, the verification will be done in 2 years from the start point, and then every 2 years. So we are collecting the data for 2 years before the verification actually happens. And imagine the size of the data for, that we are receiving daily and for 2 years. That's why we couldn't hash everything, but we hash them in batches and then store that in the blockchain. From there, we move to the verifying and approval phase, which is actually done by human. So it's still one of our weak points. We could not integrate AI into that. The reason was the changing of the methodologies. And there is no standard way to actually verify any project. It depends on the issuing registry and then what are their requirements, how to follow that. From there, that was the issuance of a smart contract, and then the credits were minted and stored in the blockchain. Finally, we were able to sell or retire the credit. The company who owned the project could actually retire the credits, meaning use them to offset their emissions, or they can sell them to someone else. But the credits were generated as tokens, so it was not possible for anyone else to double count and regenerate the credit or sell them in this case. The other project was in the transportation sector, which is actually based on offsetting the emissions by reducing the emissions was produced by that company. The company was for logistics, transporting milk from point A to point B, so it was the timing was necessary for them, the routes was necessary for them, so we tried to reduce the emissions as much as possible and make sure the integration is not affected. For this one, we have the real emission tracking system, and we have the route optimization system. The first one was tracking the trucks themselves. The trucks were implemented with tracking systems, so that made it easier for us to just track the trucks, but the other one was we're actually not only tracking the truck's consumption of fuel, but also we had to know the load of the truck to compute the full carbon credit. So there were multiple sources of data. We had to combine them all into a pipeline. From there, they were fed to the emission-saving engine, which is very basic. We haven't introduced AI into the engines following the simple methodology. It was one methodology to follow, so for this one, it was not complicated as the other one. What we did in this case was, how about using AI to actually reduce the emissions even further, using some optimization for the route and for their own business operation. For their own routes was simple. I'm assuming everyone knows what's route optimization, but for their business operation was, if they're having this XY load, actually what's the best route to, or XY load to move from A to B, what's the best way to move it? Is it one truck or more than one truck? So that was the AI part in this one. We moved then to credit minting. That data was fed into the company system itself just to enhance their process. And finally, the credit minted and put onto the on-chain, similar to the other one. So we are facing some implementation challenges for both projects, and due to some of the limitations of the actual technologies we have. The first one with scalability. So as we said, we're trying to use sensors to feed the data, or to get the data, only sensors. We're trying to eliminate all the manual entries. With sensors, if you are having trucks only, then it's possible, because trucks is simple to track. It's not that large. But most of the projects that are actually tracking or reducing emissions, either they are in agriculture or they are actually reducing emissions through their buildings. So you have to track the emissions in one building to know how much emissions you're reducing. And this is not an easy way if you're using some of the methodologies, because you have to have at least 1,000 sensors to actually track everything they have. The other one is the data quality and standardization. Again, we're facing some issues with the data quality because most of it is manual entry. We have an issue with the standardization because the methodologies are different from one registry to another, and then they actually update their methodologies frequently, so you cannot say, okay, I'll build one system that's built for that methodology. That's why we need AI to actually adapt to all of the changes and updates in the methodologies and in the system. And I'm not sure if you are following the net zero politically and all of the conferences they have and how much fights they have. You will get an idea of how many changes they actually implement almost every year. How many countries withdraw and enroll in these projects. And finally, we have the integration complexity with all of these systems. If we're using AI, if we're using blockchain, and if we are using multinationality companies where they have locations in different countries and they have regulations. Carbon credit projects, they are tightly coupled with all of the regulations in the climate change area. So that's one of the difficulties we're facing. So one of the solutions we suggest and we actually started implementing, but moving slowly, is the integration of autonomous agents. We want to implement autonomous agents for monitoring and verification. So far, we are only using human to verify all of the processes. We want to make AI do that, first to maintain integrity, and more importantly, to maintain speed. The third one, which is less important, is the cost. For verification and auditing, most of the organizations, they actually ask for at least 15,000 per cycle. So if you are doing, like, say, 2 years, then you have maybe 2 or 3 cycles, depending on the methodology. And then if you're for the full 7 years, you probably will need at least 5, we say, checkpoints. So for each checkpoint, you will pay 15,000, but the average around the world is 30,000 US dollars. So for most of the companies, it's not profitable for them to actually implement the carbon credit projects. The main reason we have talked to a few of them was the verification process being costly. So if we actually implement this with using autonomous agents and make the autonomous agents or the AI take care of all the monitoring and reporting, it will reduce the cost heavily. Also, it will reduce the time, the throughput to reach the credits, the results. The carbon credit projects, the main reason I talked a few of them was the verification process being costly. So if we actually implement this with using autonomous agents and make the autonomous agents or the AI take care of all the monitoring and reporting, it will reduce the cost heavily. Also, it will reduce the time of the throughput to reach the credits, the results. The carbon credit projects, the main reason a few of them was the verification process being costly. So we actually implement this with using autonomous agents and make the autonomous agents or the AI take care of all the monitoring and reporting. It will reduce the cost heavily. Also, it will reduce the... Asma? You can hear us?
Also, another future research direction is the branding and storytelling of carbon projects using Gen AI. Can you move to the next slide, please? Also, we can use smart contracts for automated issuance and reporting of carbon data. Carbon tokens also is another future area for ownership, governance, and transparent markets.
Okay. So just to summarize, we have talked about the current challenges and why trust is broken in the carbon credits, the integrity, all of the integrity issues, how we can use AI and blockchain as innovative technologies to solve the issues. We have presented our examples, and just the future innovation mostly rely on AI. The reason for that is blockchain has been implemented, I would say not heavily, but in average in a good way. So we have, as a result, we have in the market, we have 60% of the companies dealing with carbon credits are actually now using blockchain as of this year. So that's a great advancement in that side. But we are still lacking in AI. Thank you for listening. Any questions?
Thank you for the nice project, and I like your intent, although it's going to be very challenging because it's much related to volunteering.
Yes,
and
right.
Unfortunately, we don't have a very nice experience with such projects. So this is very related to what I've been doing for 15 years. I did my PhD in blockchain, actually. Protocols, but recently I'm not working a lot on blockchain because there is a hardship in adoption in general, and it turned out that most of the applications they tend not to really need a blockchain.
Sure.
So here comes my question. So why wouldn't go for a centralized solution? Why do you need a decentralized solution?
You mean why do we use blockchain itself? The reason why it's immutable. So rather than implementing security into an existing solution and all of the tracking all of the changes and making sure it's immutable, we thought, okay, blockchain is already there, and we are using the blockchain only to store the credits. So if we're only storing the tokens themselves and some of their metadata, which does not generate that large of amount of data, so the blockchain should be the solution.
So assume that I can build for you a database that ensures immutability,
yeah,
and retained by the Ministry of Energy, for example. Would that work?
We can try it. We're always open for our solutions. But with blockchain, it's actually the publicity of it. So it's more public than any other solution. So if we're using blockchain, then we can allow anyone actually to go check the immutability of that record.
And this can be a service managed by the government to give the service to their citizens. Everyone can see in a transparent way. There's accountability. There is credit if you want to be credited. If you don't, there would be enforcement. And this works well, for example, in countries like Saudi Arabia, because there is a lot of energy, I think, and they are the biggest player maybe in energy in the world. This is a very relevant application. And we have this wave of digital services in the country. I think this would be one of the applications that could be implemented. What I always say that blockchain is very interesting because actually it changed the way we think about everything related to blockchain. But unfortunately, blockchain is used like in very little cases, or might be used efficiently in very little cases. We can take from blockchain the abstractions that we need for our projects. In this case, you need immutability, you need accountability. We can build them on any database, a local database. You can build this and it would be transparent and all the properties that you've mentioned. Blockchain is only needed when you have transactors that they don't trust each other.
That's exactly what we have here. So we cannot, as you said, you have a country managing the database. In blockchain or in carbon credits in general, it's actually not one entity. It should not be one entity. It should be open for the company themselves to post their carbon credits and then ensure any other person would ensure, any other organization would ensure that our can trust the integrity of that. because it's in blockchain, it's not managed by one entity. Whereas with any other solution, it has to be centralized. There is some let's say, governance around it, whereas in blockchain, no, it should be open the way it is.
Right. That's correct. But in this very situation, maybe being centralized is better, because these institutes are obliged to report to the government.
That's in the mandatory market where they oblige to report to the government, whereas in the voluntary, which is the basis of our solution, it's actually globalized. So credits are being generated in different countries and sold to entities in other countries.
Okay, so I've just mentioned, I've noticed that you noticed decline in the use of carbon credits.
Yeah. Not in the use.
It's because of the trust you mentioned.
Yeah, it's not in the use, it's in the buying of carbon credits. So
Okay.
in the generation and buying of carbon credits, the credits being offered has reduced. One of the reasons is the one I mentioned. The other one is actually many of the companies, they retract and just cancel their projects, afraid of being the integrity issues being claimed later on with their projects.
Which can be controlled by the government.
Well, we have to disagree on that one then.
So that's why I'm saying. So I did a lot of analysis on a lot of applications, and everything goes in the loop and then returns to the government. Even if someone has stolen something or cheated the system or something, you will sue him in front of the court, and you will end in the hands of the government, who will protect you. So if we transform this project from volunteering-based to something that the governments would adopt.
There are similar ones in what we call cap and trade, established already like in California and the EU.
Yeah.
These are controlled by the government. But for the others where you are actually using voluntary credits, no, they are not controlled by the government. And they're used by big companies. As I said, there is a big market, and already they have been paying like $1 million just to verify a number of credits. So it's not controlled, and we don't see it being controlled in the near future, unfortunately.
Okay. So this is one thing. Another question is regarding blockchain itself.
Yeah.
So I worked on blockchain a lot, and I'm still working, and not against as a technology. But there was a lot of debate, and still going, that
Sure.
it's the most power-consuming technology, and
True.
they a lot call it waste, right?
That's true, yeah.
So it would be like a dilemma that you are using technology that's so much consuming of energy to defend the energy consumption.
That's a very good question. We actually eliminated that from the slides because of time limits. But what we did with the hashing and limiting our writing is actually to reduce the number of writes and then reduce the energy consumed. For reads, it usually does not consume as much, so you can check the credits as much as you want, almost. But for writing, it's limited to the ones when we do the hash, and it's very limited. We have done so many tests just to confirm that we're within some of the limits. We haven't published that work yet, so I cannot say anything about it, but it's more of reducing the number of writes to control the energy consumption, and then take that into consideration for the credits themselves. And we have talked about our clients and explained this very well to them.
Thank you very much. So
thank you.
I keep some time for other questions.
Very nice speech.
Thank you.
And, I do agree on the AI and the blockchain are mutual empowering, and the AI may make blockchain more autonomous, and blockchain make AI more like trustable. But I have two questions or maybe suggestions. And as you mentioned in the technical challenges, is the quality and standardized like IoT data.
Yeah.
Actually, I think what's more it's important is for the censoring data is trustable. Because there are people, they do illegal things on the sensor equipment and to make data. So I think you may make some like a cross-checking mechanism to make true, trustable and quality IoT data. That's one. Another is I saw you mentioned the NFT in the framework, but NFT is non-fungible token, but carbon credit is fungible, so it can be exchanged. So I don't think NFT is good at to mint, like credit, because credit is fungible. It's the same.
I'm sorry, were you saying fundable or refundable or? Fungible.
Fungible.
Okay.
Fungible. Yeah.
Asma, are you still with us? Because that's Asma's work, so. Sorry, say? No, it's not my work into the NFTs. Yeah.
Professor Lee, you're absolutely right that the integrity of the input data from the sensors, you're absolutely right that the integrity of the input data from the sensors is absolutely paramount, okay? The concept of NFT is not for the input data stream.
Yes, yes, Asma, one moment. Yes, that's a very good question, Professor. Regarding the fungibility part, carbon credits, we don't, it will be easier to track them if they're unique. Like if for the NFT, you have an ID attached to each NFT and you know the owner. But if you use non-fungible tokens, it will be harder to track. So that's why you use non-fungible tokens. I hope I answered your question.
Okay, thank you. Okay, probably I see.
So the idea of using the non-fungible token is not for the input data stream. The input data stream is used to collect, and you're absolutely right, ensuring the integrity of that is paramount, is used to reliably calculate and collect and generate how many carbon credits should be generated as per the governance protocols, okay? NFT comes once the carbon credits have been generated as proof of ownership for someone to say, this is mine. Instead of carrying the carbon credit itself, I'm using the NFT as a means to show this is mine, or even to subdivide that into several different parts. It's not for the input data stream. The input data stream, think of it like the ingredients when you're cooking something. I mean, in this case, the cooking process is generating the carbon credits, okay? Once you have done the whole thing, whether it is 10 carbon credits or 20 or 30 or 1, that is denoted by a non-fungible token. And I can give it to the owner and say, this is like proof that you own this thing. It's like a receipt, digital receipt, so to speak.
Okay, thank you very much.
Professor Ali, you mentioned a very profound point. I mean, this whole thing about blockchain and sustainability is an emerging research area. And as Asma mentioned that, I mean, we have done off-site hashes and all to reduce the energy, but the key fundamental driving force for us in using that blockchain technology was the need for consensus, which, as far as I know of, consensus between many different parties, and at least as far as I know, I mean, you cannot have that. You may have traceability and you may have all of that in a centralized database, but to have consensus, arrive at consensus using proof of stake, proof of work, whatever the protocol it may be, that is something that is uniquely blockchain.
If the players trust each other.
Yes.
So this is correct if the players don't trust each other. If you have the nodes, they trust each other.
And this is a completely unregulated market.
Yeah. Thank you.
Thank you.
Okay.
Any other questions?
No.
Hello. Yep. Thank you. It's a very good discussion and very relevant topic in today's age and time. So my question is like maybe it's I'm just thinking loudly, or maybe take that as a suggestion. So when I am like in Australia, when I'm signing up for those different energy provider, then they ask you that $1 or per week for carbon offset. And I never sign up for that. And my main concern is about the transparency and trustworthiness of that system, that, okay, they will detect money from me, right? But do they actually do something related to environment or not? So maybe that can be another area where you are, once you are looking into the volunteer side of it, but also looking into from the consumer side of it, that providing a service that those who are caring about the environment and maybe attending all those conferences and paying the big fees, but they don't know that does it translate to those carbon offset which the companies, the big player, they are promising it. And for that, that can be like some sort of transparency that what you are doing with the blockchain, providing that a service that, okay, a consumer who's paying this amount of money per week, per month, per year, how that translates to, or what they claim by that company that, okay, we have done this around a carbon offset, does that really they do it or not? And immutable things that with the blockchain, that will be a good way to show them to their customer that this is what we have done, rather than going to their website and showing that we have done this thing, and there is no proof for that.
Yeah, I think it's related to this one. So what you're talking about is more of done at the individual level, where the token does not represent a whole credit, but we are breaking down the credit into multiple tokens, I should say. So the number would depend on how large the project is. We can refer to this. We have actually done some research into that. It's personal carbon credits or personal tokens, and the collective, let's say, product would be a whole carbon credit owned by that company. So this introduced another issue with ownership. Who owns actually the carbon credit? Is it the company or the individual themselves? And how do we manage that? We're still in that research area. We haven't, because there's no much regulation around it, and there's no methodology to actually define it, and then we move from there. So it's a very good point. Thank you.
Thank you.
Thank you very much for such a nice, informative discussion.
Thank you.
As I observe from the credit marketing is going down from 2 billion to in around 700 millions in couple of years. So my question is, should we implement more sophisticated smart contract layer to monitor the project metrics? What do you recommend?
Sorry, can you please repeat the question?
I'm saying you need to capture the market. So should we make more sophisticated smart contract layer to monitor the project metrics or not?
Do you mean existing projects or?
Yes, for the existing project.
So for existing projects, it's going to be difficult, because if you want to generate the smart contracts for existing projects, so are you actually relying on verifiable data? So we still have an issue with the integrity. Some of them are already doing that, like they have the smart contracts, they have the tokens, there are some carbon markets which implement blockchain. But when you see their methodology, it's still the problem, the issue with the background work. So once the credit has been issued, they start building the other solution based on that. But our issue is solving the life cycle from the start until we mint the credits, not after we mint the credits.
Again, the issue is like Dr. Ali Shokak says, so why not we move to the centralized form?
So again, the issue with the centralized form, you cannot confirm later. Our solution is based on both. So we have the centralized to store all of the data, the streamline, but we have to have this hashed into the blockchain for verification later on. If we only have it in decentralized, then it's controlled by one entity, and this just, it's the other side of the solution, which is not providing the verification process that's necessary to ensure the transparency.
Thank you.
Thank you. Any other questions? Thank you very much.
Thank you, Dr. Asma Mustadi and Dr. Asma Al-Khalaf for this information, for sharing your expertise. Prof. Chow, you can come to here, please.
زي تيجي سلك أول حاجة
And then what's the new development with the AI, what's used to be, and what's the new norm of AI, then Gen AI, that's actually, it's been around for almost 3 years and more. And we're gonna dive a little bit in the LLM and how these LLM actually working, this is the giant models. Then if we wanna build this LLM, how we can build it, we're gonna walk through these steps. And then we see the killer application of like these LLMs, which is RAG, Retrieval Augmented Generations. And then we finish with the AI agents, how we build our own AI agents with the tutorial. Okay, if I ask these questions, what is AI, like maybe 5 years ago or maybe 10 years ago, everyone will imagine it's like robots doing some automations. But if I ask you these days, most likely you're going to tell me it's about ChatGPT. This is an AI. But actually, this is not the only AI. Actually, more than that. Any task can be automated. And human intelligence is actually AI. Whether it's informed generative AI or it's the traditional AI, all these actually AI. And these actually, they have capabilities to automate tasks actually done by human. And they exhibit like some intelligence, but not like the intelligence with like a human do actually. AI actually is everywhere, even before generative AI. AI in these companies, Amazon, YouTube, Gmail, whether you realize it or not. If there's a spam, no spam, this is actually AI. A recommendation system with Amazon, YouTube, it's all AI. Self-driving car, these even, and the appliances in the home, it's all AI. Or maybe the camera on the streets, this is actually utilize AI to capture whether this actually driver is violated or not. Even Google Maps, auto completions, all these actually powered by AI. But not AI what we know right now, it's the traditional AI, it's like a machine learning and deep learning. And we don't need actually AI to do a lot of work. Maybe some work actually we don't need AI at all. Similar to like if I want to sort some emails, this is just short scripts can do this job. No AI actually needed. Similar to inventory management. Inventory management actually, we don't need actually AI, unless if you want to predict something, this is actually where AI comes in. But if I told you like I identify every person on these pictures, that's actually where we need actually an AI to help me in that task. What I would summarize AI, like in the revolution since probably in 50s till now, it's in this triangle, or I call it AI triangles, either data, algorithms, and infrastructure. when the probably computer came out, we didn't have like much of that data, and the infrastructure was actually not actually, let's say, advanced compared to what we have right now. Even the algorithm wasn't developed. And whenever we get more data, more like advanced algorithm, advanced infrastructure, we're gonna get stronger and more intelligence AI. This is what I recommend, we call it AI triangle. AI models before, like in pre-2017, people try to figure out whether this is a croissant or it's actually a cat. It's based on the CNN and other AI models. We were trying to figure out these numbers, whether this is 3 or not, the 100 digits. And even there was some trial like with speech, like if I want to convert speech to text, and like some object recognitions in that era. But with the generative AI, actually, these become actually easier to test with what they call transformer models. These transformers architectures are actually powerful. They can capture that patterns and predicts a lot of actually useful like outputs in that sense. So Gen AI actually is AI model that actually generates whether it's text, video, audio, any other like kind of output. And part of actually that Gen AI is there is to call LLM, which is actually large language model. It's a language model based on transformers. It's fed a lot of data. It's been training for probably more than maybe a month or so until we get maybe GPT-3. I'm not sure about what GPT-5, maybe it's been 6 months for training. And this actually capable to predict actually just the next tokens. Whenever I feed this token, it will generate the next token, and then this token is going to become in the input and generate the next token, and so on. This is actually iterative operations. And probably you're familiar with these LLMs, whether it's ChatGPT, Llama, Cohere, and there's open source model from Hugging Face. So where generative AI actually fits in that AI space? AI, it's actually more broad. Then there's a category called machine learning, and part of that machine learning there is what we call deep learning, and within that deep learning actually there's generative AI or Gen AI. So the main actually task that generative AI actually can perform is which is called text generations. It's basically just to generate the next tokens. That's what you're going to see in ChatGPT. This first token, second token, third token, it's like every time it generates one token at a time. If I tell ChatGPT or other AI models, so just me like 10 places to hang out in Gilsim, it will generate this kind of response. And actually, LLM applications go beyond these actually generating text. Could generate text, classifications, probably can do by now a lot of things beyond actually what the text as actually mentioned. So now LLM is actually everywhere. So you can see LLM in Google recently. So whenever you search about something, this is actually powered by LLM. You can see LLM part of your Gmail. You can write there your like emails and do a lot of things. You can see like as a copilot in your operating system. This is actually LLM. And in your phone, even nowadays with database, like if I want to query database, I usually use like what they call SQL. Now actually SQL powered by LLM, so I can write this kind of query to probably give me description for every city I have in my database. This is all powered by LLM. And LLM actually they have different capabilities. Not actually they can do everything, of course. There's some capabilities they excel at and capabilities actually not actually that good at. For example, reasoning is actually, LLM is not actually powerful in reasoning, even though they exhibit that kind of reasoning, but not actually, if you give them like hard problem, most likely will fail. But they are good actually NLP. NLP, it's been a lot of models actually been trained in the like 2017. It's all just for an NLP, like for just maybe classifications, sentiment analysis. Now actually LLM can do all this as one model. So if I want to just describe like some terminology for LLM, there's what we call context window, which is the size of the prompts that you can give to the LLM, which is actually max. It used to be for little, now it's almost 120K like tokens as input. Mainly you can put like a lot of PDFs, documents, like books as inputs. And this is what you call prompts. And each LLM has some what you call parameters. So the more parameters, most likely it's more capable to do a lot of things. That's what actually meant with the parameters. And there's different kinds of model. There's multimodal, just maybe for text. Another model is for images, or could be multimodal, like hybrid, like can merge a lot of things as one. And in terms of the output, there is what you call inference. Inference means I get the output from that LLM. I have that LLM trained. I ask that LLM, give me some like output, so it will, we call this actually process inference. And there is temperature. Temperature is actually to control how the model will be creative. Like if I set it to 0, almost like will be deterministic. If it's like 1, it's like more like maybe the random, the results that you will get. So how actually LLM works? Like if we get this as a prompt, Mustaqbal University, I just fed it like to any LLM. The first token I will get is, then I will fed again the is to the input again, then I will get A, then I will get privates until I will the full sentence. This is actually how these LLMs are working, is just talking at a time. So how I can train that kind of a model. So let's go back to the AI triangle. So I need data, algorithm, and infrastructures. So for the data, I can get the whole actually internet data, like the public crowd. Could be trillion tokens or maybe more. Then I need infrastructure, which is basically GPUs. And once I get this GPUs, I need algorithms. Basically, the adopted right now, it's transformers architectures. And then I will get something similar to ChatGPT. And if we see the numbers for GPT-3, which is actually released in 2020, they've been trained in 1 trillion token, and they use 1,024 GPUs, which is not actually powerful GPUs, just V100. And the number of parameters for that model, it's around 175 billion. And we get GPT-3, it's been training like for 34 days, and it cost them around 4.6 million. If we see different numbers, like this year, same like recipe, here the data, you see it's 40 trillion like tokens, and number of GPUs, it's almost more than 100K, and it's actually H100, which is more advanced, and number of parameters 109 billion, and I get Llama 4, which is actually released in last April. This is, I'm not sure how long it takes them to train, but probably weeks. There's a problem actually with LLMs. LLMs tend to hallucinate, meaning give you like different results or something. Could be like correct, but actually not correct. They don't have access to real-time data. If I ask them maybe what's the sessions today and then ISP, probably wouldn't tell you. They actually bias on their results based on what their data they train. If they train on maybe US data, will most likely be biased on that data. And actually, we need lots of infrastructure to run these actually LLM, which is actually sometimes expensive for like small businesses. So how we can improve actually LLM? There's 3 ways to improve LLM, either by fine-tuning, or prompt engineering, and lastly with RAG. if I want to start with the first one, fine-tuning, it means I get like any open source LLM and train that LLM with any data like business domain that I want LLM to be trained. Like if I want to train LLM on KSA law, after the training, I will get LLM specialized in KSA law, which is actually not something easy, but this is what they call fine-tuning. The prompt engineering, actually, it's to give like the LLM specific structure to guide the LLM to actually behave like normally. Either given like few shots, meaning like give them like this the task that LLM you need to perform and some example, and then the LLM it's turned to what now classify that's the problem. This is classification's problem. If I give that like instruction to LLM, and I will ask LLM for the last one, give me the sentiment analysis for the review for the last sentence, I will get negative. Now the LLM understand like what I need from it to like give me the correct results. And it could be prompt engineering with persona, with text, with formats, tone, and so on. Like it's lots of you can do with prompt engineering. Now let's go to the third one, which is RAG. It stands for Retrieval Augmented Generations. Basically, since LLM they don't have access to my data, I need to give that LLM data to answer. So for example, if I ask LLM, will not give me that answer. Or maybe ChatGPT nowadays, if you're gonna search, but most likely you will not get it because the LLM doesn't have access to your own data. So how we can solve this problem? We can solve actually this problem by tell LLM, okay, here's the piece of data that actually has all the tags of the ISP, or maybe the folder of the ISP like programs, and then give it to the LLM. And the prompt with the context, now the LLM will able to answer me correctly about the session that's actually happening at ISP. So this is basically a RAG, and usually there's a lot of things you need to do with the data. You need to vectorize that data because you need to do similarity check, or maybe you can use just maybe keyword-based search. This could be work both. And now people like in the industry, they use both keyword-based and vectors. Now let's switch to the AI agents. AI agents, it's what I call this year is the AI agents year, 2025. What's actually AI agents? Basically, it's a software that can do a lot of things by its own with actually goal-oriented. It's different than bots, different than assistants, it's agents. So what's the difference between bots, assistants, and agents? Bot is actually rule-based, programmed. Like it's, if you see the WhatsApp response in probably 3 years ago, it's all based on the bots. Assistants, it's like similar to ChatGPT. I ask question ChatGPT, I get the answer. But if I want like something beyond that, most likely I will go with agents. So the agents, I can give that instructions, and the agents probably gonna do a lot of steps until it gets me to the goal. And here's the main components of any probably AI agents, even though there's no like standard definitions for our main components. But eventually, you will need some agents for routing to see where you need to handle that task to. And you need a memory, because the agents will do a lot of steps, and then we need to remember what I have done in the last step. And there's some tools. Agents can access to tools. Tools could be anything. For example, here, are there any current discounts on smart TV? That question is, if you send it to any ChatGPT, most likely you didn't get something maybe locally. But if I build agents, it's going to go through Jareer, Extra, and so on, get me the deals on TV. Then after that, I will search, like I will give that answer to LM, and LM will summarize that answer to me. Like here, usually LM in router, LLM for the outputs, even sometimes LLM as a tool. So what kind AI agents will like can access? Could be a database, could be a Python script. So the LLM writes a Python script and execute by itself. Or could be calculators, it could be access to the web or Google, or maybe any like documents they need to access. So here I have different kinds of agents. One is what they call reactive. Basically, I give the agents like questions and it will get answer. Reflective, it means it will see if the answer is actually correct or not. Tool using, that agents actually specialize in tool using. I will use that tools, or maybe if that's prompts regarding to my employee, I will go to my database employee and so on. And there's agents planning, that I need to plan how I can accomplish that goal. I need to do step 1, step 2, 3, and so on. And there's what we call collaborative multi-agents. I have like a lot of agents, they work together to accomplish one task. That's what they call multi-agent interactions. So what difference between agentic and non-agentic workflow? So basically you hear this term agentic, non-agentic, or agents. Agents is just actually a subset of agentic. Agentic, I have like workflow, I need to like the agents to do that workflow for me. So if we see these definitions here, is a process where AI agents can act autonomously with like goal-oriented and with multi-steps. I have this example. If I want LLM to schedule me a meeting, or if I get email asking for a meeting, I will do with these steps. So first step, I'll get the email. Second step, I will go to my calendar in my Gmail, for example. Then there's the reasoning. I will say, okay, this I need to schedule that meeting. Then I'm going to draft reply, and that reply it will be sent or maybe approved by the user. This is the steps, which is agentic. Non-agentic is if I ask LLM to summarize this kind of text. This is actually not agentic. So there is actually a level of autonomy for AI agents. It could be as operator, like the user involvement with the agents actually more than the agent itself, or it could be as observer, like I just run the agents, I will not doing anything, the agents will take the actions by its own. And there is something in the middle, the user involvement and the agents, like similar to what they call consultants. The more we go on this sides, the user actually has like more power. In this sides, like the agents has more power than the users. So there's actually many AI agents framework, and now it's actually getting popular, but this is probably one of them. There's LangGraph, Agno, there's N8N, which is popular for automations work. Some of them actually easy to use. They already built the agents. All you need just put your data and use that agents. Or maybe some of them you need to build from scratch your agents through the like similar to LangGraph. And there's tools what they call N8N, which is actually drag and drop. All you need just put your components of that agent. It will perform the steps that you actually already described in that actually framework. I will show you like some example with N8N and Agno, and then some like LangGraph in the next. Do you have any questions before I jump to tutorial itself, like show you some agents in actions? Okay, I think now is the time to see the agents in action. So first, I will go with the N8N. So this is actually agents just based on drag and drop. What's doing this agents, actually it will get some, this is the tools that agents actually using, some news from tech news and world news. It will summarize that's actually news. How the agents actually will be summarized using actually ChatGPT. First, it will get the news, from that tools, then you can use ChatGPT to summarize that news, and then it will send that news to my email. So if I activate that agent, this is through N8N. See, this is the first step. It's already, I guess, get the news, and then I think now it's the summarizing step. And now, actually, the email is being sent to my email. I will give it a little bit. Here you go. I get the email of the summarize of today news. This is the world news, and this is the tech news. So this tool actually is easy, just drag and drop. Now it's actually complicated. Probably you need some learning curve in the beginning. Just put these boxes, but eventually it's not actually that's actually complicated, and it's recommended by everyone, not even for a specialized person. Okay, now we're gonna move to the other frameworks, Agno. Here we're gonna use a Colab. Basically, Agno is a agents framework. It's already, they built a lot of agents. So you can go to their website and scroll and browse their AI agents. I picked some of their agents. So here is a simple stock analyst. Basically, this agent is going to go to Yahoo Finance as a tool. When I ask that agent get the current stock prices and recent history for Aramco, it will go to Yahoo Finance and it will retrieve all the stock prices, and if you have like any additional recommendations could give you. And this is the agent while it's thinking, and this is the tool is being used, and here is the final output I get by executing that agent. Okay, and the next agent, this is, I just built that agents quickly. It's basically, it will get news from online, so based on the KSA, tech news, and then it will make that actually the news as like reporter. If I can see the results of that news. So first of all, this is the prompt. Tell me about a tech breaking news story happening in Saudi Arabia. It will go to that tool. DuckDuckGo basically is similar to Google search. It will find any news related to my query, and then it will pick one interesting, and it will format it as I explain in my prompts. So this is the output of that agent. If I can see that my prompts, basically, I tell that agent you are enthusiastic news reporters, and I describe what actually I'm expecting the output could be, and this is actually the agents following my instructions and give me that output. Okay, next agent, it's going to be ISP support. What's ISP support? Is basically I will get the documents of this program, this conference. It will index that documents and can ask any questions related to the documents. This is one of the agents can do that actually. Here's actually knowledge, the knowledge that I will build, and here's the reference, basically from the conference website. And if I ask the agents what talks will be on the first day, it will think, and based on the data that I fed it to the agents, it will answer based on the documents. Here, I guess this is the first day of the conference. Basically, it will have this kind of schedule. Okay, lastly, in terms of the Agno framework is agents number 4, which is financial deep research. This is what I call multi-agents. So it's not one agent, actually a lot of agents working together to build me like deep research. So the first agents, it will get some sources from the online.
And the second agent, it will do like similar to Yahoo Finance. It will go to Yahoo Finance, try to find any kind of news related to what the topic that I am interested on, and then these two agents will work together to build these deep reports or deep research. Here's actually the questions they ask. What's the market outlook and financial performance of AI semiconductor companies? I want that agent team to build a deep research. So here actually you can see there's a lot of tool calling. So DuckDuckGo, the search, the first one, second one, third one. It's been doing a lot. I think it took me like 5 minutes, maybe more, just to finalize the outputs. And here is the answers that I get. So here's the executive summary about the semiconductor and some numbers, even some recommendations, diverse, recent news, and all that stuff. This is actually happening by combining two agents together. One agent is actually doing the research, getting the interesting insights, and other agents actually getting the actual numbers from Yahoo Finance. Okay, and lastly, I will show you like agent from scratch. That agent actually, I haven't built myself, but basically I went to ChatGPT. I asked ChatGPT to build me an agent, and that agent, it will basically go into my Gmail. It will get like maybe the most recent 10 emails, and it will draft me a response for each email of that. So here's the code. I'm not going to go inside this code because it's all related to how to deal with Gmail, how to connect with the Gmail. You need some tokens for Gmail and as well OpenAI as well. I think the main part here is actually here's the agents what we'll do actually. It will summarize and it will write drafts, and then it will put it in my Gmail. So I'm just gonna run this agents, and I will just go to my inbox drafts. Now it's nothing here. We're gonna wait for probably a couple of seconds. So now I get drafts from the agent itself. Like so here's the drafts. The agents actually wrote that's the draft from me. Maybe there's some setting I can increase here we go. So I have this draft, this draft, this draft. So if I go to the agent itself, here's some logs. Basically, it read the first email, created the Gmail draft, second email draft, and so on. So now I'm just telling the agents to not send that email just as a draft. But you can also send that email. When you get a reply, you can reply again, and so on. So this is what's agentic actually in action. That's actually pretty much about AI and AI agents. Not sure if you have any questions. Yes, please.
Thanks for this nice presentation. I want to ask about how to evaluate agents.
That's actually a big topic, how I'm going to evaluate agents. There's actually many ways, and basically if I tell agents, if I want to evaluate agents that I built, first of all, I will see the results. I will just try it, test the results. Maybe if I'm going to let the agents write me an email, I will see how quality of that email actually. It's actually correlated to what I intend to build or not. This is one way, it's just manual. And there's some framework actually for the evaluations. But it's not easy to evaluate LLM, but we can get some sense if that agent is doing what I'm supposed or what it's supposed to do or not. And there's some agents built for, let's assume if agents is doing from text to SQL. I ask text as just prompts, then it will switch from text to SQL to get me answer database. So I can build that data sets. That database is just for evaluation that agents. I will let the agents to run over that data sets and see the response. So either basically you can do it from like manual or by building like data sets, and then you need to figure out what's the root cause of that actually failure of that agent. So maybe the agent is actually doing well, but maybe the LLM itself is actually not good. Maybe you need to switch to other LLM. Or maybe there's some parts of the agents, if I have multi-agents, one agent is actually not doing the work. So it's actually deep and still actually active research to how to evaluate, not even for agents, even the whole LLM as well. Okay.
Thank you.
Any questions?
Thank you. It's a very good presentation. Agentic AI, agent-based system, that is talk of the day nowadays. Everyone want to build an agent for themselves who can work for it, and your talk helped with some of those, I think, difficulties with that. I hope I will build an agent for replying my emails, and that's where my question is. So how we give access to some of those paid subscription, like for example, if I'm doing a deep research on some of the papers on IEEE, which is behind a paywall, then how we integrate that into our agents.
Okay, so if you want to build agents, do you have access to the IEEE?
Yes, I have through my university, like that's an example, but then there are some other subscription, like the one that you have, that you did a news to send you the news articles, but then those are the publicly available news.
No, actually,
right?
nothing here in subscriptions. It's all actually open source.
Yep. So if you have a subscription, then is it prompt for a username and password, or how that will work in that case?
Yeah, that's good questions. Actually, some agents need some authentications. So before I activate that agents, you need either tokens or you need username, password before the agents actually can do the work. For example, if I'm gonna, as your example, IEEE, there's actually authentications. Before actually I activate the agents, I need to give the agents my username, password, or something, tokens, if actually they have APIs. And by the way, there's APIs, I'm not sure if you are familiar with the APIs. APIs meaning like I communicate with systems through APIs. IEEE will provide me APIs, I can collect data easily. This is one easy way. If not, there's no API, you can do it through authentications.
And this brings another question that maybe you are not able to answer. That's what is the legal implication of that if I'm scraping the IEEE data, right, and creating a research report out of it, and that's for my own personal purpose, though will the IEEE, they will come after me that I have scraped all the papers and created something out of it, and they clearly say that you are not allowed to that, and that's where I think a lot of cases that is going on OpenAI right now, that they have done some scraping of the data. It's nothing, you don't need to answer that, but just a question, if you have any thoughts on that.
I'm not really sure about the legality of like scraping data, either like public data or behind like authentications, but I think there is what they call etiquettes within, if you go to any website, there is bot.text. If you go, you can see the policy, whether you are allowed to scrape or not to scrape. But essentially, people said anything like public, it should be public. So we are free to scrape.
Thank you.
Thank you.
Okay, nice talk. Thank you very much for your presentation and research topic. My question is how to prevent the hallucination when constructing the custom AI agents.
So okay,
to prevent?
Hallucinations actually can be, as I mentioned in my talk here, either by strong prompt engineering, or maybe if it's actually beyond prompt engineering, you need to fine-tune. So fine-tuning meaning you predict what LLM actually to give. Like if I want LLM always give me either negative or positive. I don't want LLM to give me anything beyond that. So I need to fine-tune LLM to accomplish that task. This is like other way. Other probably prevents hallucinations is basically selecting or picking the right LLM, since we have a lot of LLMs, and probably some LLMs are actually good at one task, and other LLM is actually not good at other tasks. Similar to if I want to translate to Arabic, some LLM may be good at translations, other LLM maybe not. So here's the ways to combat hallucinations, but actually there is no like 100% hallucination free. Could be some hallucinations.
So there can be some dangerous consequences for this hallucination for the people using the AI agents or ChatGPT.
There is some, can you get your questions?
Some dangerous consequences.
Dangerous, it's based on your applications. If I'm assuming you build agents to trade behind, like on behalf of you, like buying stocks, selling stock, maybe that's actually dangerous. But if just writing drafts, basically, yeah, another way actually to combat hallucinations, a human in the loop. So you need to human either to approve before like complete the task, or maybe in the middle of the task. This is another way to combat hallucinations.
Okay. Thank you. Thank you.
Very instructive. Thank you very much. And I have some comments and further comments. You may agree or you may not agree, just for your reference. And you lecture, the prompt engineering and the fine tuning and RAG, yeah, is a mainstream solution, as I know. So further, I think for the prompt engineering, which may make a suitable fine-tuning solution based on the drug knowledge, and then make the fine-tuning. So the three elements to collaborate and to make a concrete, solution.
Yeah, you're right. So you can actually combine fine-tuning with RAG, like you.
It's dynamic. It's a dynamic. The prompt engineering and to make a nice prompt and also nice fine-tuning solution based on the RAG. The three elements combine, interact with each other.
Yeah, I agree. Like this is what I mentioned here is possible solutions. You can combine, actually. I'm not saying like you just go with the fine-tuning, don't ignore prompts. No, actually, even if you're fine-tuned, you need some prompting to tell the LLM how to behave on behalf of you.
For some prompt, they may not have good like a RAG date. So, there could be a fine-tuning solution, but for some prompt, they have more related RAG information, so they can have different, like fine-tuning solution.
Yeah. I mean, the fine tuning is actually just changing the weights of the LLMs. But RAG, actually, you need it anyway, because if I ask ChatGPT what's happened last hour, of course, ChatGPT is not being trained every single minute or every single hours. These, we need actually RAG capabilities. So ChatGPT, it will go to probably Google or Google search or Bing search, trying to find the news, then it will fed it as what I mentioned in RAG solutions.
Yes, I know you. You present the mainstream solution and the surveys, and it's very nice. And I just have some idea on the for reference.
Yeah, I mean, yeah, you're right. You like what I see in the industry, they combine all these together. They try first out of the box LLM, maybe Llama. Then if Llama is not working with their use case, they need to fine tune that LLM. Then usually they see some improvements, but sometimes not actually. The problem with the fine tuning actually is the infrastructures. You need the LLM in your infrastructures, and then you need GPUs. GPUs, it's usually like almost maybe double what actually you need for inference. If I need like 4 GPUs for inference, probably I need 8 GPUs for fine tuning. I'm not talking about the training from scratch. I'm just talking about fine tuning. Training from scratch, this is actually needs a lot of GPUs, a lot of data, and so on.
Okay. Another point is about the agent. For you present a Gmail agent and also the multi-agent system, and but my view is the new generation of agents are based on large language model, right?
Yeah.
But for the new agents, I don't think the traditional workflow still work well. So I think the better agent framework should be rule-based and other than workflow-based, because like the Gmail use response, but for large language model-based agents, it can can make the decision or make a task directly. Do not need like action level, like orchestration or something. So but for the workflow is based on action. But for the language language model based agents, they do not need like action level, like it's very dynamic and knowledge based, and they can fulfill a task directly. Do not need
Yeah. If you saw the slides, there is actually agents actually based on rule-based, based on like more human interactions, and there is autonomous agents. Basically, don't need human involvement. This is like different level of agents, but either like agents need actually these kind of actions, and these actions based on either connecting with APIs, for example, what we saw Gmail. I have Gmail APIs, but I don't want to go by myself to do that actions. I will let the agents, okay, the agents, here's my email, here's the emails that I got, drops me a response. Now the agents will take that actions. So maybe this actions doesn't need LLM. The actions, it's actually just maybe retrieving the last 10 emails. It will, once I get these emails, now the LLM will do the drafting for the email. For each one, it will drop them and post it to the Gmail.
Yes, but my point is even there are different level of agents like respond, reactive, like recognize or something about agents collaboration. But my point is they have different direction for LLM-based agents. Even for reactive, it should follow the direction of like a RAG, like parameter engineering, like fine tuning to have better performance other than the traditional like workflow based on the action orchestration or something.
Yeah, I mean, I agree with you. Most likely we are getting to there. I'm assuming in the future we will see agents build another agents and then doing a lot of actions. That's what actually I conceive in the near future. And actually, I'm not talking about 10 years ago. I'm talking about maybe 2 or 3 was going to the agents and actions a lot.
Yeah, I just provide ideas.
Thank you.
Okay, thank you.
Oh, can I just see your opinion? Okay, I know it's not part of this. Your I mean, it's agents, but not much to do with a small language models rather than LLM.
So your question is about small language model?
That's right. Yeah, how the agent might work in the small language models.
Yeah, I mean, these agents, each agent's probably equipped either with tools or with LLMs. So that LLMs could be large or could be small, based on what actually type of agents you are building. If I'm building agents, it will classify either this email wants a meeting or not. This is just simple classification. I don't need to go with ChatGPT or large language. I can go with a small one, maybe 70 billion parameters. It will do the job.
Yeah, I can see your point. Yeah, that's. I mean, I'll give you an example. Okay, right. So you have a small language model, which is not in depth in engineering, and the other one in business, or the other one on social science. They are very different, and so and then because they are so specialized, and then the beauty of it, you don't need to evoke the large language model engine to retrieve some information, which is time consuming, and then it wastes a lot of money as well. So one way, another trend at the moment is to go for the small language models.
Yeah.
Now, if we have multiple agents who try to achieve a common goal, now we got to. I mean, I've got a problem is going to have a semantics problems, because when you talk about engineering is very different from the social science.
Yeah.
It means in the context of that. So we're going to have some kind of problem like that. I'm just giving example. Okay, I don't have an answer. I'm just seeking your opinions, because since I've been working in the area.
As I said, like this kind of things like new, and people like trying different kind of combination, whether it's small language, large language, and they combine together all this together. So still there is no like standard and best practice in building and utilize these agents in action. Thank you. Is there any questions? Okay, thank you all. Appreciate it.
Thank you for attention. Thank you, Dr. Abdulaziz, for this presentation, for sharing your expertise on this topic. We would like Prof. Chow, please. Prof. Chow.
Thank you.
We are now moving to Engineer Fayyad Bayan from RGM. I would like to thank Rina Del Majd, RGM, for their support to us, and they are supported sponsor for this conference. I would like to thank Engineer Fayad, please. حياك الله. أهلا وسهلا. I'd like to thank Engineer Fayad Bayan, now the lecture about AI for leaders and decision makers. Rina Del Majd has a lot of projects regarding transformation, digital transformation, and we hope, inshallah, find a lot of information this. I would like to thank again Engineer Fayad. I know he's busy. Thank you for your time. Go ahead.
السلام عليكم ورحمة الله وبركاته. حياكم الله بياكم سدد على الحق خطانا وخطاكم. Actually, I would like to thank Future University and IEEE and all our organizers and partners for this fantastic event. It's very good starting for AI within the region, within Qasim region. I'm going to summarize my session because this is the last one. And I'll focus on critical points and let's say the vital points. If there is any need to go deeply or zoom in for any topic, just raise the flag. I'll go deeply, inshallah. Okay. Let's start with this quote from Elon Musk. If AI is unleashed, we will be like ants before it. You know this quote, you know this famous, let's say, billionaire, trillionaire, I don't know, okay. So now look at the size of the human, look at the size of the ant. So this is what we will face. Are we ready as a leaders, as a managers, as a top management? كده أفضل. Okay, thank you. So let's go for the future. Now, let's start with NVIDIA. Last October, NVIDIA reached to $5 trillion as market cap. The first company worldwide which reached to $5 trillion. What is $5 trillion? Let us compare with countries, with Germany, with the UK. Look at this statistics. United Kingdom, around 3.6, the GDP of all country, United Kingdom, the great empire. Do you remember it? Okay, what about Germany? 4.6. No, NVIDIA is larger than Germany. The factory of Europe, the factory of Mercedes, BMW, you know it? Siemens, all of GDP around 4.6. What about continents? South America itself, including Brazil, Argentina, Salvador, blah, 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 around what? Around 4.2 as a content. What about Africa? All countries within Africa is 3.1. So why NVIDIA reached to 5 trillion? Because we will face new era, new lifestyle. Are we ready as the leaders, as the managers, as a top management, as decision makers for this era? So today, I'll try to summarize how we can start. As leaders, as a top management, as decision makers, I'll try to put the cornerstone for this era, for this future, for this challenge. Okay. Inshallah, we will cover around 4 items, small 4 items. I'll go quickly for all. First, we will brief RMG as a Saudi provider. Then we will see what about AI disruptive impact on industries, education, healthcare, transportation. Our impact on our life as a social, as a human. Then we will see what is AI systems. Small overview about AI system. I need the leader to understand the whole picture, the big image. There is no need to be coder or developer or technical man to be AI leader. Just I need you to understand the main concept. Then we will see the role of leaders in the AI adoption and adoption. We would like to accept this giant. We would like to accept this change. Then we would like to cohabitate with it. We would like to adapt this change inside the university, inside ministry, inside authority, inside council, inside our home, inside our houses. Okay, then finally we will see the practical methodology. Steps, step by step, around 5 or 6 steps, practical steps, clear steps to implement AI within small organization, medium organization, large organization, within private sector, within public sector, within non-profit sector. So let me start with the RMG. We are very happy to be here in Al Qasim. This is the 3rd or 4th participation in this area. We are working with the Qasim Emirate, and inshallah we will be, let's say, digital transformation arm and enabler for this region. RMG provides its services through 9 capitals, starting from Tunisia, Tripoli, Cairo, Riyadh. We have offices in Dubai, in Oman, in Kuwait, and nowadays we provide our services from headquarters in Riyadh, and we are very happy to be with you within this event, within this fantastic event. We have more than 300 experts, starting from digital transformation, data, AI, cybersecurity, quality management systems. We implemented more than 1,000 successful projects, and we have around plus 300 happy customers across the region, more than 75 awards and certificate of thanks and recognition certificate. I would like to invite you to visit our innovation lab inside Riyadh, the intersection between King Salman Road and Abu Bakr as-Siddiq Road, to see how we transform any challenge, any business need by using innovation, by using, let's say, virtual reality, AI, by using robotics, by using 3D printers, by using blockchain. This lab represents our hitting heart for our efforts during last 2 years. We tried to provide the lab for all equipments, and we will be happy to host you within the lab to see our AI use cases, applications, and so on. We have many relationships with international groups, internally and externally. And also we have our, let's say, quality office and risk management certificates for business continuity, for IT service management. We have many ISO certified level around 9 or 10. Here we have a brief about the achievements specific for AI. I think you have seen Rinad, the robot outside. Rinad can speak with you. The accent, the Saudi accent, any accent, Arabic accent, she can communicate with you, she can provide the information, she can remember you, and also we would like you to challenge her, to train her more. Okay. Now let's start with the core ideas about the presentation. AI disruptive impact, what I mean by this one. Let's start from positive side. Anything within the life, there is positive face and there is negative face. Let's start with positive face. Could you hear about Anguilla or Anguilla? Very small island in Caribbean Sea, or let's say very teeny island in Caribbean Sea. The good luck of this island give them the ability to register domain ends with AI. That's it. This is the good business for this island. By luck, good luck. So nowadays, any company is looking for domain ends with AI. So, oh, great, I can sell out. I can sell out what? I can sell out nothing. Just organize the relation and registration process. Create a portal. There is no need to put advertisement. Automate the process, create payment gateway, then all world will come to this island to buy domain. One of domain reach up to 15,000 USD dollar. Just domain. So look at this change. As a leaders, are we ready to see the opportunities? AI is borderless opportunity era. So there is no borders, just to create the portal and I can generate income, I can increase my GDP, I can invite investors, I can invite more innovators to create their own headquarters in my tiny island. So this is the first impact. Positive, okay, everyone, I like it. I need positive impact within my economy, within my life, within my society. Look at the other side, which is very sad. Okay. You know, within USA and Canada, Czech company was the famous provider for educational platform. If you have homework, I can help you to solve this homework quickly, and I can give you tips, I can give you more information. So, but this is all the story. After ChatGPT, this company goes down dramatically. Look at this statistics. They lost 99 from stock value or from market cap. Before ChatGPT, the market value for this company was 14 billion. Okay, a huge provider across USA, 50 states, across Canada. Okay, then after ChatGPT, this number goes to 0.20. What about the revenue? Before ChatGPT, they have 776 million as revenue per year. Now, they will go down year by year. What about the stock value? One stock cost $130. Now I can buy the stock for 1.5. I can buy this share for 1.5. Look at the huge impact, negative impact, dramatically, fastly, within 2 years only. So, as a leaders, are we ready to face this AI impact? Inshallah, we will create some ideas, we will give you some tips about this area, about this challenges, about this chance. We have good chance if we can play the game with the big players. So I need you to take a look for this AI architecture. It's very simple AI architecture. As a leader, I need you to understand only the main abbreviation. When I'm talking about AI infrastructure, what I mean, let's say servers, racks, storage, networking, racks, and so on. So I need AI infrastructure to operate my AI applications. Then the middle layer, which is AI model, for example, large language model, as my colleague displayed before, large language model. Also, there is large action model. So I need AI infrastructure. Then I need AI model. This model will be installed on this AI infrastructure. This model will represent the brain, the digital brain. And now I can generate, I can develop, I can design AI applications for meeting users, for analytics, for productivity. I would like to use AI as a leverage tool, productivity tool. I cannot start without AI infrastructure, without the proper AI model. Now in Saudi Arabia we have Allam, right? As a large language model. So as infrastructure inside Saudi Arabia, what we have? We have two options. The first one is on-site option. If you belong to ministry, to authority, to commission, to council, you have large number of employees, you have sensitive data, so you have to plan to create your own AI infrastructure inside the ministry. And now there is exception for, let's say, for big ministries such as Ministry of Defense, Ministry of Interior, Ministry of Health, to create their own AI data centers locally inside the ministry. So the second option, if you are a small organization, if you are a university, non-profit organization, you can use cloud option. You can use Saudi cloud option. We have STC, we have, let's say, Saudi Google, we have Saudi Azure services now. Here, I put some brief about, let's say, the hardware. If you would like to buy hardware for on-site option. Till now, there is one provider only. Do you know it? NVIDIA. 5 trillion will goes to buy what? DGX as a AI unified box prepared from processing, storage, networking, ability to learn, everything. Single box, single platform, you can buy it. Then, if you have more need, you can go for DGX rack. If you need more, you can go for DGX base board. Then you can go for super board, or let's say AI factory, based on your needs, based on the processing which you need. Okay. What about the cost of this one? Let's start with the first one, the smallest one nowadays. If you would like to buy DGX 100, H100, the smallest one, around 500,000 USD. So what about the latest one? Around 750K. This is the default one, the normal one, the smallest one, without any configuration, without any efforts, without any additional GPUs. So it's huge investment. So as a leader, you have to see, shall I need on-site or cloud? If I need on-site, what is the proper size for me? Okay. Now let's go for leadership section. Now I have idea about the future. I have idea about the AI impact change. Let us see what is the main role of leader within any organization. If you read about all schools within the leadership, all schools said there are 3 main missions for any leader. The first one, foresight of the future. Envision the future. Read the future. I need you to read between the lines. Where is the future of education? Where is the future of industry? Where is the future of healthcare? Where is the future of utilities? So this is the mission of leader. Read the future, to envision the future. Then I need you to formulate the proper strategy. صح? I can read the future. I see the opportunities. Now I would like to create my own strategy to reach the future, to gain the benefits. So the third one, supporting the organization's transition from comfortable zone to growth zone. Now all employees is interested to be in the comfortable zone. I know this task, I can do it, I can do it every day, there is no need for a change. So this is your own role, to move people from comfortable zone to growth zone. Encourage people to learn more about AI as a productivity tool, as a leverage tool. I need AI to accelerate my performance, to save money, to raise my productivity level. So this is the mission of leader. Now in Saudi Arabia, we have big, ambitious target. Highness Crown Prince Mohammed bin Salman has set an ambitious national target. We would like to be among the top 5 countries globally within AI as industry, as factories, as applications, as models. So this is our national target. We would like to move our universities, our organizations, our private sector, our non-profit organizations to meet this goal, to support this goal by 2030. let's take a small look for statistics about the current state for AI leadership. According to Deloitte report 2024, there is big gap in boards of directors when you are talking about the knowledge of AI, the implementation of AI. For example, 79% of board members lack knowledge of AI, even the basics. Even, okay, what is the difference between AI application and the AI model? What do you mean by AI infrastructure? What do you mean by GPU, CPU? All of them. So 2% of board members are expert in AI. This is the lucky company. 45% of board members have not discussed this topic at all last year. There are quarterly meeting, yearly meeting. Okay, nobody discussed how I can use AI within my factory, within the university, within the company, within the ministry, and so on. So the impact of AI-aware boards, AI-aware leadership is very obvious. For example, companies with AI-aware boards achieve 5% increase in revenue, 28% internal adoption of modern technologies. For example, let's see these opportunities. Let's try to compare the success of using AI and the failure of using AI. The first one, we have successful story with Siemens. They trained the board on AI concepts, ideas. They could doubling revenue and saving millions after this training. We have other example for Unilever. They trained around 3,000 employees to use AI, to adapt AI within the process, the procedures itself. Look at the benefit, 40% increase in innovation products across last 2 years. From the other side, there is European Bank, tried to use AI without strategy, without framework, without proper planning. They lost 45 euro last year, 45 million euro last year. So the leader is very important. I would like to see the future, then I need to create the proper strategy, then I need to develop proper framework. So, is there any skills needed for any leader within AI era? Yes. There are 10 top skills. It should be within your mentality, within you, within your team, within your organization. The first one, emotional intelligence. The second one, the agility, the flexibility. The third one, empathy. The fourth one, cultural intelligence. Let's see number 5, critical and creative thinking. I need to train my employees about the techniques of critical thinking, about the techniques of creative thinking. Also, I need the ethical judgment as a leader, as a top management, as a board. I would like to learn more about ethical judgment for any area, for any phases. Also, the human being, the accountability, the courage, and intuition. These top 10 skills, I need you to read more about it and try to share these skills, try to bring those skills to you and your team. Okay, let's go quickly for the methodology. The idea about this methodology, we would like to create clear steps, small steps, let's say obvious steps with phases for any AI leader. The first one is very important. Look at this AI implementation roadmap. We have 5 phases. We have 5 areas, key areas. The first one, lead AI awareness initiatives. This is the first corner. I need you to conduct the AI awareness campaigns, creating the schedule for workshops, for training, for seminars, for webinars, name it. The second one, which we have seen before, develop a comprehensive AI for your organization, as a university, as a company, as a factory. I need customizable strategy based on my target. Then I need to apply academic methodology. We will see the steps, practical steps. Step 1, step 2, what I can do, what are the audience, what are the outcomes, we will see now. The fourth one, I need you to implement ethical AI governance framework. You need to create the proper policies, the proper processes, the proper procedures, the proper governance framework to direct and control AI applications. Then I need you to support the business and technical requirements because you will face new requirements day by day. Okay. Is there any question about it? 5 steps, simply. We'll go deeply within academic. Okay. Here I have summary if you are preparing to create your own AI strategy. Start with the vision, then the mission. What I mean by vision and mission, I would like to clarify the desired future directions and how to work towards achieving major goals of university, of company, of factory, of ministry, and so on. Then try to design the proper values within this strategy. What I mean by values, it represents the most important principles about this strategy within the organization. Then I need you to specify strategic pillars. What I mean by strategic pillars? Strategic pillars represent the main or key areas on which the strategy is based to achieve its vision and mission. For example, I would like to concentrate on customer, so customer centristic. I would like to go for cost reduction, generate profit, minimize the risk, name it. Then you have to design the strategic objectives, the big goals, high-level, long-term goals that the management aims to achieve in the long run. You can use a SMART technique for it. You can use balanced scorecard. You can use OKR. You can use theory to change. Based on the context, you can select the strategy school tool. Okay. After defining the strategic objectives, now I can defining my initiatives, my projects about AI applications, about large language models, about large action models. Shall I need to automate my process line? Shall I need to digitize my environment? So I need to create specific projects within this part. Then don't forget to specify the enablers. What I mean by enablers? It represents the framework, the resources, and the skills that will be used to implement the strategy. For example, your team, your data, your agility, your, let's say, your management system, and so on. Okay. Also, remember that if you provide the right guidance with tracking the progress, you can reach to successful project. So it's very important to define KPIs. How many objectives you have? I have 2, 3, 5 objectives. You need to develop KPIs for each objectives to measure the progress. Okay, here let's go deeply with academic. This is the last phase for this presentation. We have practical methodology with 5 steps, and here we have explanation about each one. This methodology allows leaders to implement AI within small organization, medium organization, enterprise organization, or giga organization. Let's start with the first stage. The first stage, you can start it tomorrow, starting from awareness phase. I need to build understanding about AI and align on its potential and impacts. I would like to align with the benefits, the potential benefits, the potential income which I gain. What is the target audience for this phase? As a leader, now you are going to develop the plan. So you can start from executive team, from leadership, from top management, then go for middle management. Don't forget all employees. Try to design 3 levels of programs, one for top management, one for middle management, one for all employees. For example, as activities, I can conduct workshops, I can conduct webinars, I can conduct seminars, I can design dedicated training path for special people, for technical people, for business people. So this is the first area, the first key area. I need you to give this area, let's say, importance, efforts to start with strong cornerstone. Then try to collect information about the business challenges, the pain of business. Now, you are working within the university, you are working within the company, go for each department, ask them about the business challenges, business problems. Try to collect information, try to be a listener. There is no need to go with strong debate with them and try to argue them. Okay, try to listen. Try to collect information, just focus on collecting the full picture. So here you need to organize peer-to-peer meeting, or you can conduct workshops for directorate, for departments, for sectors, but I prefer to go peer-to-peer. It's better to collect more information, accurate information. If you go to the finance department, go to financial manager. Try to sit with the leader. Try to sit with the gatekeepers. Try to listen for them. Ask them about the problems. What are the current problems within finance department? Okay. After this phase, go back to your office, close the door, start read between the lines about the collected information. Remember, you need to read it 3-4 times because some information will be not accurate. Some information is not cleared. Some information needs to be connected with other. So I need you to calm down, sit alone with your own team, with AI team, with technical team, with design team, study the information. Try to specify where I can use AI. Where is the return on investment? Where is the easiest area to start? Then we can go for design. State this state represents what I need to design the proper solution to solve a problem, to solve a challenge. You can list down the problems, you can list down the challenges, then you can create a priority scheme, then you can start with the most important one. Shall I implement all AI initiatives? No, I cannot. Shall I implement 70%, 90%, 80%? From my advice, from practical, let's say, word, if you implement 40 or 50, it's very good. Start with 40, 50, it's enough. Try to design the application, focus on the simplicity, try to do it simple. Try to understand, let's say, the outcomes of this application. Put the technical side away. Focus on the business, on the users. Then, once the application is ready, once the solution is ready, go for implementation. Before implementation, I need training program for employees based on their levels of technology, based on their ages. So if this employee has 30 years, if this employee has 50, is it similar? No, we would like to design customized training programs for them before implementation. Then I can start what? I can use my AI application day to day to facilitate my job, to increase my productivity, to leverage my processes. Of course, you will face improvement opportunities. Collect all improvement opportunities, put it within continual service register, within CSI register, and try to prioritize the improvement opportunities. I cannot implement all improvement opportunities at the same time. So I can do this within this quarter, then the second one, third one within the next quarter, and so on. This is the brief about ACADIC. If there is any question about it, I would like to listen to you about the content, about the ACADIC methodology, and about the small tips. I hope I could deliver fruitful information and fruitful cornerstone for leaders and top management. Thank you for all, and we would like to open the door for any queries. Thank you. Please move the mic.
First of all, thank you very much for your very comprehensive and very insight presentation. And you know, look at from very different perspective. Really, most of us are more like engineers. Really, now have a look at this one and say, "Wow, okay, that's very interesting." And I think at the moment what we are facing, okay, and the AI, as you just say, make a big impact, but mainly on hardware companies, not the software companies. A lot of software companies at the moment, in fact, they attract a lot of investments, but I mean, not many, even OpenAI, haven't really making money yet. In terms, you know, so that presents a challenge for us, really, how to convince a company to invest so much, as you mentioned earlier, you know, resources and then time, everything, and to build something which is, I'm not sure. And the second question, okay, it's money related because, as you can see, it already what 5 trillion now. People just think, oh, will be become a bubble, and people think, oh, yeah, it can't become a bubble. How can I invest something in the bubble? That's not good as well. So you know, sorry, what to do with the finance, and how can we convince that? To see your opinion. Thanks.
That's great. Actually, the easiest way to convince leader to invest in any technology, just do small use cases and small benchmarking with similar organizations. For example, nowadays we are working with a government entity. The first question when I met the representative, he said, Abu Hadi, what is the ROI of this use case? I said, I have similar one in other organization. He said, oh, great, let us visit them. Okay, we visited the other benchmark organization. When he saw the ROI, he said, Abu Hadi, go ahead, we need this one. So try to create small benchmark, small use cases, focus on the numbers. They will accept if they see the numbers, if they see the input and the output, if they see the ROI, they will say, okay, that's great, let's go with this one. That's it. Any other question?
I do agree AI is basic and necessary for any company today. So my question is, how do you think about the AI bubble breakdown, the risk, especially when a company got a $5 trillion of marketing value? So when we make the AI strategy, should we consider the measures to make the company more resilient, more robust to survive the possible bubble breakdown?
Yeah.
Actually, we got the internet bubble breakdown in 2000, right?
Yeah, yeah.
So that may copy to AI.
Sure.
Isn't it?
Actually, I'm totally agree with you. We are facing, let's say, AI bubble. And we are living inside the AI boom. So when this bubble exploded, okay, you will say, okay, I prefer to be within this boom, within this bubble, to gain anything. So the idea, we cannot stop. We are inside the bubble, yes. There is AI boom, yes. So shall we stop? We cannot stop. Because this is a huge change for life, for industry, for education, for healthcare, for social itself, for our human. So we would like to reserve seat within this bubble, within this journey, within this risk journey. So, but we can mitigate the risk. We can create mitigation plan. We can focus on our Saudi needs. We can focus on our community. We can check how we can use AI to be leveraged for oil and gas industry, for here in Al Qasim for our agriculture and process, and so on. So we would like to reserve seat within this race. We cannot stop. This is my opinion.
Okay, thank you. You know, basically, I think AI now has its knowledge level. AI provides knowledge, but the knowledge now is cheap. Like me, I have knowledge, but I cannot get money.
Sure.
So,
Totally agree with this point. Done? Okay. We would like to thank you for this decent session. Thank you for all.
I would like to thank Engineer Fayad Bayan from RMG for this presentation. Actually, when somebody talk about labor market from practice, it's another thing. So I'd like to appreciate your sharing this information. Thanks a lot. And in the same way, I would like to thank your support us as a sponsor in this conference, bringing your famous lab, and actually all the visitors are happy with Rinad. Thanks a lot. Thanks a lot.
Thank you. Thanks for this starting point, inshallah, and I hope we can cooperate more for further cooperation and future events. Merci, يعطيك العافية دكتور. Thanks. Barakallah fikum. Good starting. Yeah, it's a small one. I hope we can enlarge this, let's say, business path. So it's very good to speak about technical path for AI, but we would like to focus more on business path. Yeah. Oh, that's great. Thank you.
Now we are finishing this today's schedule, alhamdulillah. I hope everyone have a good experience with this day, inshallah. Thanks a lot, and see you, inshallah, tomorrow.